Tradoon.
A dirter.
Ontogeny.
Tradoon. reboot the system first.
The door locks! Ellie, boot up the door locks!
It's a unit system. I know this. It's all the files of the whole park. It tells you everything. I gotta find the right file. Oh, this is it. This might be the right file.
Hey, Poggers, can I get a Twitch Prime?
Good.
Slam it.
There we go.
Smash it.
This isn't the right file. This might be the right file.
Mobile PC, I know. I mean, this part is good, but I want to delete this part. Move to your left.
This isn't the right file. This might be the right file.
I was laying in my bed last night thinking about that, bro. Like, if I just, like, took a shovel and I just started to dig into my grass, I wonder when I'd hit the ocean, bro.
This isn't the right file. This might be the right file.
How am I supposed to compete for content when he has a kid? All right, I put my cat on stream sometimes for content, and it gets me like a 2 minutes of why people happy before chat gets bored. If I had a kid,
This isn't the right file. This might be the right file.
uncle.
This isn't the right file. You got it! Yes!
Dinosaurs lived a long time ago. They were terrible lizards, don't you know?
This is it!
Some ate plants, some ate meat, some ate fish, and some ate beets. Well, hello, everybody, and welcome back to Paleontologizing. So good to see all of you here today. Sorry I'm a little bit later than I was expecting, but I had to spend some time at the museum this morning, doing some collections work, and, yeah. Getting back via public transit is sometimes a little time-consuming, but here we are. If it's anybody's very first time here, then allow me to introduce myself real quickly. My name is Danny Anduza. I'm a dinosaur paleontologist. You probably know already that a paleontologist is a fossil scientist, rather a scientist who studies fossils. Not a fossilized scientist. I don't know any of those, but a scientist who studies fossils is called a paleontologist. I'm a dinosaur paleontologist in particular, because I study dinosaurs. Dinosaurs are what I dig up, what I publish on in the scientific literature, what I present on at scientific conferences, and what I talk about 4 days a week here on Twitch. We're doing 4 days a week now. Anyway. Most paleontologists don't work on dinosaurs, so I want to make that very clear right from the start. But I do work on dinosaurs, hence dinosaur paleontologist, and that's what we'll be talking about today. We've got a brand new Tyrannosaur. Well, a purported new species of Tyrannosaur. Not a new genus, but a new species. Just described last week, just published. So we'll be talking about that. We'll be looking at the original scientific paper. We'll be kind of weighing the evidence and talking about why it may or may not be valid in the long run. This is going to be an interesting, nuanced kind of discussion today, so I hope you're ready for it. But it should be fun. New Tyrannosaur. New Tyrannosaur specimen, at least, from Mexico. So we'll talk about that and why that's geographically so important, too. But yeah, that being said, let me go through chat and say hello to everybody. And, we'll get this thing kicked off. By the way, thank you, Newbie Muffin, for the raid. I really appreciate it. Anybody still here from the Newbie Muffin raid? And I'm glad your stream was good. You said, you're talking about genetic modification on today's stream? How it works and the ethics behind it? Very, very cool. That's neat. I don't know a whole lot about that, as a paleontologist, but I'm sure it was fascinating. I might have to check that out. Everybody, if you're not yet following Newbie Muffin, think about doing so. They are evidently a scientist. Let's check this out. About. There we go. You just found the channel of a cheerful but clumsy girl that so far is really enjoying getting to know new people and still having a chill hangout session. Very cool. Let me go ahead and follow right here. Thank you, Newbie Muffin, for raiding in. I really appreciate it. It's good to have you here. Who else do we have? We've got Mayfield Pemberley and Claire Burr. We've got Murph. And I remember seeing Matt M33 and Kodali at the very top of chat as well, before I even got started here. Mite Shiny and Sloppy Salamander, Dan D. Him and I Am Morvosh, Grim Deviant, and Mudder Toad, who came in with Newbie Muffin. Excellent. And Phonix Flamey. Hello, hello. What is this? This is Paleontologizing. Buckle up. Jaro, how are you doing? Hello, hello. Arita Wife and Luke XY. Soraphaginax and Steely Dan. Sinja Minx and Dasher Fernando. Hello, hello, everybody. It's good to have you here. Alright, making my way down through the chat. Chris VC and Danish Viking. The Lenina, how are you doing, Lenina? Hello, hello. Hope you're having a good day at work. Jay Quartz, how are you doing? And Brick, hi to you too. How are you doing? Jedi Mega Man and Dr. Prince Bones. Dino Dax and M. Scoggins. Alright, approaching the bottom of chat. Alright, crunch time. We've got Neilf. We've got Victorious. We've got Cool Island Song. How are you doing? Welcome back, Cool Island Song. I hope you're doing well, Doug. It's good to see you again. We're going to be talking about this purported new Tyrannosaur that Longreach just published. Second author, I think. We'll talk about it. And Pandora X-Durg. How you doing, Pandora? Beer Pong Champion. Hello to you. Thank you for gracing us with your presence. You can put the trophy right over there if you want to while you sit and watch. But welcome, welcome, Beer Pong Champion. Make yourself comfortable. And Dr. Terminator, how are you doing? And we've got an animation about the new Tyrannosaur, do we? Is this from Paleo GDY? What is this?
This is
interesting.
This is the horizon, which marks the extinction of the dinosaurs.
Hang on a second.
This level, and out in here, there are dinosaur
Rogan.
fossils. Above this
Thank
level,
you,
in these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
There you go.
Rogan 27 and their 8 raiders have stumbled below that level.
I can hardly believe it.
Of dinosaurs.
Joe Rogan himself and his 8 raiders. Hello, hello, Joe and everybody else. Welcome to Paleontologize. It's good to have you here. Thank you for joining us. Not quite, says Rogan. No, you're better. Thank you for being here. Thank you for the raid. I hope you had a wonderful stream. It's good to see you. Welcome back to Paleontologizing. What did you get up to? Tell me about it. We are about to discuss this brand new, well, purportedly new dinosaur just described. It's based on very fragmentary material, but it appears to be a Tyrannosaur from Mexico. All places. Very cool. Labocania aguilinae, I believe? Labocania is the genus. I've known about this guy for a long time, this particular genus. Lovely VFX there. I really like that. Holy cow. Thank you for sharing, Dr. Tara. I hadn't come across that yet. Really nice. Rogan says we were looking at 1890s era electrical power generators. Very cool. Some cutting edge stuff there. I hope it was fun, Rogan. Thank you again for rating in. I appreciate you. Welcome, welcome. Yeah. Oh, and Claire, thank you. Look at that email. I will do that. I've been so busy today. It's been nuts. Got up at 4:45 this morning. Doing chores, doing errands. Then I went off to the museum to do some specimens work. Looking through museum collections, gathering data. And, yeah, just got back a little while ago. Less than half an hour before I was supposed to start. So, yeah. Anyway. It's been a busy day already. But we're here, and we're going to be talking about this purported new dinosaur. And here to join us, ladies and gentlemen, is Sweetie Pie. Hello, hello, Sweetie Pie. How are you? Yeah. You gonna be looking for more attention today? She was really hogging the stream yesterday, weren't you? You were just right up there by the camera. Yeah, you gonna do that again? Got Cam here. Yeah, and hey, Shiny Jewel, how are you doing? Yeah, this is Sweetie Pie. She is very sweet, as her name would imply. That's why we call her that. And she's one of my landlords here. She loves to push the camera around. She always dreamed of being a camera operator. And now she gets to do that. Oh, sweetie. She's come to investigate our new background for the day. Here. We've got Tyrannosaurs highlighted in today's background. And a lovely Mexican flag, too, because our purported new Tyrannosaur is indeed from Mexico. Sweetie Pie. Being real aggro with that camera. Goodness. What do you think you're doing? What do you think you're doing? Huh? Yeah. Yeah. And, Carl Lawler says, what's the chance the new Tyrannosaur breathed fire? Pretty much zero, fortunately. Or fortunately for that animal. There's a reason animals don't go around breathing fire. It's because it wouldn't work, you know? Like, that's... You'd blow yourself up. Anyway. And a Sweetie Pie is sweet. What's Moon Pie? Lunar? Loony? I don't know, Little Pink Pony. Sweetie Pie, what are you doing? She's like chewing on the camera arm. You better not be chewing on the cable. What do you think you're doing? Why are you being so aggro about that, huh? What's up with you today, huh? What's going on? What's going on? Oh. Yeah. Yeah. And hey, Diagonal, how are you doing? Hello, hello. Sweetie Pie, let's get you... Let's brush you a little bit, and then let's give you some treats. How does that sound? Is that a good way to start off the stream? Miss me? Sorry I was gone this morning. Sorry I was gone this morning, huh? Yeah, but I'm back. I'm back. I'm back to see you. Yeah. Yeah. So much extra fur. I haven't been here to remove it for you. Been gone for like 2 weeks. TwitchCon and IRL streams and stuff. I've been elusive, and I'm sorry about that. I'm here with you now. Alright, let's get you some treats, huh? How's that sound? Yeah. There you go. Enjoy. There you go, Casey Snowhorn. Yes, indeed. Oh, sweetie pie. Oh, sweetie pie. Ooh, good stuff, huh? Well, don't let him get away. There you go. And Jay Court says, what's the farthest you've ever gone to dig? Most of my excavations have been in Montana, Utah, and Wyoming. So the furthest from the San Francisco Bay Area would probably be eastern Montana, I would think. Yeah. Around like Ekalaka, Montana. Southeast corner. You get them all, sweetie pie? Is that everything? Nice. Well done. Good for you. Good job, sweetie pie. Yeah. Good job. Anywho. Yeah. And now for the tail in the mug. Yeah, there you go, Jody Fish. You know the drill. Sweetie pie, what are you doing? Look at your whiskers. Look at your whiskers. Look at those. Look at those. Yeah. Aww. You know, I've really got to start talking about these fossils, sweetie pie. I know you really want to be the star of the show. I understand that that is the case. I understand that's what you really want, but, you know, I have a responsibility to the viewers to talk about paleontology, you know? It's true. Don't give me that look. You know it's true. And look at those whiskers. Look at them. Look at them. Yeah. Oh. Oh. Yeah. Cat stream now, says Samikin. I mean, we shall see. We'll see, huh, sweetie pie, won't we? Anyway, cat whiskers are very interesting, little pink pony. Those modified hairs, evolved for sensory perception. Pretty cool. What are you looking at over there? It's funny, there's a crack in the wall right here that goes directly to the exterior of the house. And so she can smell the outside through there. So sometimes she'll come up onto my desk and she'll just stick her nose up to that crack in the wall and just smell whatever's going on outside. Huh, sweetie pie? Yeah. Are you looking in a chat soul right now? Yeah. Holy cow, sweetie pie. Anyway, sweetie pie. I think at this point you've kind of overstayed your welcome. I know you're very eager to spend some time with me. We could do that after stream today. How's that sound? How's that sound? Yeah. Yeah. Oh. I need to set up like a bed or something for you over here, where you can just rest on the desk, but not be immediately in front of the camera. Does that sound like a good idea? Should look into that. Yeah. Anywho, we are gonna start talking about this purported new dinosaur here. A new species of Labocania, which is that genus, the original, what is it, Labocania? What was the original, the holotype species, type species for Labocania? I forget. Let's take a look, actually. There's a lovely book that I've had since I was a kid called Dinosaurs and Other Mesozoic Reptiles of California. Let me show it to you. It's, here we go. By Richard P. Hilton. Dinosaurs and Other Mesozoic Reptiles of California. Here, Sweetie Pie, we gotta watch out. Moving parts, moving parts. There we go. Oh boy. Highly recommend this book. Dinosaurs and Other Mesozoic Reptiles of California. Now let's take a look at the actual dinosaurs here. There we go. Labocania anomala, an animal about 2/3 the size of Tyrannosaurus rex. Molnar, 1974, was found by Harley J. Garbani in northern Baja California in the summer of 1970. And so we actually talked a little bit about Harley Garbani. He's a guy who's got kind of legendary status in the history of Maastrichtian dinosaur paleontology. I think we might even have a clip from our visit to the Western Science Center just last week. Here we go. Or maybe not. Is that one not up on YouTube? I guess it's not. Shoot. No, here it is. Here it is. My mistake. Jump to this part over here. I'm like 75% sure it was Dynamoterror as an example of that. Yeah. There's a lot of Harley dinosaur fossils. Berkeley, actually. Go. So Harley Garbani lived here in Southern California. He was trained as a plumber. But he found so many super important dinosaur fossils in places so like... So here's the guy who discovered this genus of dinosaur, for which there's a new species just published. Lovely T-Rex skull right here. Southern California. There's Harley. And it doesn't matter if it's green, black, blue, and it's turned to stone, it's a fossil. An outstanding fossil hunter, like Harley. I think that's a gift that you were born with. I was about 8 years old when I found this fossil here in San Jacinto Valley. It really perked me up, and I never quit the fossil business. I just kept at it no matter what age. This is wonderful.
And Harley's importance to the museum is enormous, and not just to the museum, but also to paleontology in general. He built an enormous collection for the museum.
SVP award?
The
board there at LA County Museum decided that they ought to have a T-Rex. So I was asked if I would be interested to go to eastern Montana.
That's where I used to dig.
And
Yeah.
see if I can find a Rex.
I'm trying to find a book by Jack Horner that talks about Harley Garbani.
Extremely important contributions to the field of dinosaur paleontology without having a PhD, without having an academic training.
I've been collecting about 80 years.
There we go.
And I haven't run out of any fossils yet.
Very cool.
To find any teeth in the animal, I mean, meat eaters are hard to find.
The discovery of the T-Rex growth series that Harley
These are the
found,
T-Rex specimens on
the
display
baby,
in
the
Museum of Los Angeles.
juvenile, and the adult were of tremendous significance because collectively they represent the most significant growth series of Tyrannosaurus rex in any place.
It had to be Rex. It had to be Rex for the size of the element. The first thing I saw was the broken toe bone in the back.
This is so cool.
I knew it was attached to something. Everything was basically all disarticulated.
I hope we can find these videos on YouTube later. I hope they're available. But yeah, here's the juvenile T-Rex specimen.
That's a cast of it. The Jordan theropod is what it's called. I recognize this one.
It's mostly the snout up there.
The grocery list, yeah. So yeah, basically, the museum in Los Angeles wanted some Tyrannosaurus specimens, so they sent out their pitch hitter, Harley Garbani. Jack Horner talks about Harley in his book, The Complete T-Rex. There's a picture of Harley Garbani right there. The next great T-Rex hunter after Barnum Brown is this gentleman, California plumber Harley Garbani. Yeah. Harley grew up on a farm in the San Jacinto Valley. Like me as Jack Horner, he found his first fossil when he was just 8. When he was just a kid, 8 or 9. His wasn't a dinosaur, it was a piece of camel leg. This find hooked Harley on fossil collecting. He kept hunting through high school and after marriage in World War II in the deserts of Southern California and northern Mexico. That's where he discovered La Bocaina. He got so good at finding stuff, the Los Angeles County Museum of Natural History hired him to collect for them in the summertime. In 1965, the museum had the good sense to send Harley, his wife, and daughter to look around eastern Montana, where Barnum Brown had discovered the first T-Rex. Harley wasn't looking for T-Rex only. I'd collect every fossil from mice to T-Rex. I just loved beating the bush. Beating around Lester Engdahl's ranch in the Hell Creek Formation Badlands north of Jordan, Montana. On July 27th, 1966, Harley came upon the darn thing. Some large foot bones sticking out of a bank. Right away, Harley knew he was on to T-Rex, and more. He also found an Albertosaurus buried with it. Which is not actually Albertosaurus, but whatever. Yeah, I was pretty excited. I didn't figure another of those suckers would be found, Harley said. And he was pretty sure he'd found one. I'd seen enough of Trachodon, which is Edmontosaurus, to know this was something bigger. The skull that Harley excavated is now on display at the Los Angeles County Museum of Natural History, and it is the biggest T-Rex head on view anywhere, nearly 5 feet long. That's funny, that was the case when this book was published. Jack Horner's, The Complete T-Rex. There we go. But some Tyrannosaurus that Jack Horner discovered subsequent to that were actually bigger. It's kind of funny. Things change quickly in dinosaur paleontology. Anyway, Harley Garbani is pretty famous. At least among us dinosaur paleontologists. Yeah, I'm seeing if there's any videos about him, and that's kind of strange. The first search result is the video that we were just watching. My stream from the other day. Demuni's, hey Ray, thank you for the follow. Welcome to Paleontologizing. Good to have you here. There we go. From the Telegraph. Harley Garbani, who died on April 28th at age 88, this is April 28th, 2011, was a self-taught paleontologist credited with unearthing some of the most significant fossil finds of recent years. There he is with a big T-Rex maxilla right there. It's the big tooth-bearing bone in the upper jaw. Garbani, a former plumber, whose home was a California trailer park, began collecting fossils at the age of 8. For the rest of his life, he prowled the deserts and badlands of North America, searching for the telltale glint that it might indicate a presence of fossils. He unearthed woolly mammoths in Baja California, excavated duck-billed dinosaurs, and relieved termites of tiny prehistoric mammals' teeth they were taking into their mounds. It's actually ants, not termites, but whatever. Professional paleontologists regarded his facility for finding fossils with a mixture of envy and awe. Lowell Dingus, research associate at AM&H in New York, devoted an entire chapter to Garbani in a book about dinosaur hunting, observing that he had worked out from decades of experience in which kinds of rocks he was likely to find them. In 1965, the Los Angeles County Museum of Natural History commissioned Garbani to locate its first Tyrannosaurus rex. And he did. Within a year, he discovered the world's third specimen of the terrifying dinosaur. Only the world's third specimen. Well, there's a few like minor ones in between there, but the third major specimen, I would say. It took 2 years to extract the bones from the rock, but what emerged was one of the best preserved T-Rex specimens ever found. Its 5-foot skull and legs were largely intact. Its legs are larger than 5 feet. There are also ribs and a jawbone full of jagged teeth. This huge skeleton is on display at the museum, locked in mortal combat with another Garbani find, a Triceratops. So that famous T-Rex and Triceratops that you see in the foyer of LACM, the Los Angeles County Museum of Natural History. I think they're still there in this pose, right? Harley Garbani found both of these, which is nuts. Seen in the movies, yes, many, many times. Since the Los Angeles Museum is pretty close to Hollywood, it gets featured in a lot of museums. It's pretty famous. Pretty famous pairing, those two. Yeah. Harley Garbani found both of those. Anyway, so we're just kind of talking about this dinosaur, Labocania, and who originally discovered it down in Mexico. It was Harley Garbani. Right here on the left, in the white cowboy hat. Another example of important fossil finds being made by people who are not professional paleontologists. Pretty cool. Big paleo salute to Harley Garbani. So anyway, laying the groundwork for today's discussion, we're talking about Labocania. So, Labocania anomala, an animal about 2/3 the size of Tyrannosaurus, was found by Harley J. Garbani in northern Baja California in the summer of 1970. It was described by Ralph Molnar, or if I'd gone to Berkeley yesterday, I would have run into Ralph again. He's another dinosaur paleontologist. Anyway, yeah. Described from a fragmentary skull and postcranial material as a new genus of theropod. Labocania gets its name from the late Cretaceous La Bocana Roja Formation of northern Baja. The formation is late Cretaceous but older than the overlying El Gallo Formation, which is about 73 million years old. So here is an illustration of this dinosaur. It's being portrayed as an abelisaur here, isn't it? Yeah. Bizarre. There's a general consensus that the animal is nowadays probably a tyrannosaur rather than an abelisaur, but kind of takes us into today's news, you know? So yeah. Yeah. Oh wait, and DM Wing says, did I misunderstand? Was he not a full-time fossil finder? No, Harley Garbani was a plumber by trade. Let's see if we can find some info. Harley J. Garbani. Well, in the Los Angeles Times, they had a long article, an obituary about him. He was a one-time plumber who gained unexpected renown pursuing his lifelong avocation as a fossil hunter, who discovered some of the world's most significant dinosaur fossils. From Mexico, like we're talking about today, to Montana, self-taught paleontologist Harley Garbani spent decades prospecting for bones in the Badlands where bedrock is exposed. He also amassed some of the finest collections of Native American artifacts in Southern California. Luis Chiappe, who we saw in that video, said, Harley was a very passionate fossil hunter and someone who understood the scientific value of fossils. He didn't have any academic training in the field, and he didn't do any research, Chiappe said. By not doing any research, Luis Chiappe means that Harley Garbani didn't publish any papers. He would just go out and find the material that would be studied by academic paleontologists. He was primarily a field person, and he made some truly unique discoveries.
Join us as we unravel some of the mysteries of these incredible creatures from our past.
Well, well, well.
Lizards.
Mr. R. Knight, how are you doing? Welcome back to Paleontologizing. Good stuff.
Knight and their 73 raiders want to hear about those terrible lizards.
Welcome, welcome. I hope you had a wonderful stream. Tell me about it, if you're not too tired. And V6 Sonoma and Chef Ubero, how are you doing? Hello, hello. And how did you too, Mr. Knight? I hope you had an excellent stream. It's wonderful to have you here. Thanks for joining us. We are going to talk about a brand new, well, purportedly new dinosaur just described from Mexico. And we were talking about... It's a little complicated. The new dinosaur is called Labocania anguillinae. Let me make sure I've got this right. Let's see. Labocania anomala is the original species known from Mexico, and now there's a new purported species, also from Mexico, just published last week. Labocania anguillinae. I'm trying to lay the groundwork talking about the discovery of the original Labocania first, just so that we all kind of understand that. And then we'll be better equipped to talk about whether or not this new dinosaur is actually new. Whether we can say that for sure, because it is based on very fragmentary material. So yeah. A tacosaur, a tyrannosaur actually, Chef Ubaro. Very funny, yes, indeed. Anyway, if anybody's here for the very first time, let me introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist, so I'm a scientist who studies dinosaurs. I talk about dinosaurs 4 days a week here on Twitch, and answer viewer questions, go over fossil news, interview other paleontologists, and during the summers, I'm out there digging up dinosaurs, doing it live on stream in Wyoming and Utah. So yeah, if you've got any questions at all, don't hesitate to ask. Anywho. And we were working on the deathless attempts of Donkey Kong Country 2. Well, well. No country for Donkey Kong deaths, apparently. I hope it went well. I hope you didn't die at all. Thank you for joining us, Mr. R. Knight. I really appreciate it. Thank you, thank you. And that's the best Donkey Kong game? Really? Better than Donkey Kong Country 5? I don't know if they made 5 of them. Very cool. The second one's better than the first, huh?
Let's protect our fossils, because if they're removed...
Pontus?
forever.
I really appreciate it. Is that the Pontus I know from Twitch? Pontus, thank you for the Prime. I appreciate it. How are you doing? It is. I see that wrench. How you doing, Pontus? Hello, hello. Glad you could join us today. We're talking about... Well, I'm going to get into this, but a new paper was just published last week on my birthday, actually. Yeah, purporting that there's a new tyrannosaur species from Mexico. We'll be diving into the weeds on this one. We'll be talking about if it's legit or is it dubious. It's based on very fragmentary material. So this is going to be an interesting discussion. It's going to be a complicated discussion, but I'm here to walk you through it. We're going to have some fun with it. And I'm good too, Pontus. It was wonderful seeing you at TwitchCon also. I hope you're doing well. I did run into you at TwitchCon, right? I ran into so many people. I'm 95% sure I ran into you at TwitchCon, Pontus. Yeah. Scoops is gonna get schooled. In a good way. Yeah. And partner party, there we go. That's what I thought, Pontus. Yes. It's good to see you again. I hope you're doing well. And we had another message from Mr. Knight. Mr. Knight also says it was great seeing you at TwitchCon. Thank you. I appreciate that. It was great seeing you too. Welcome back. And thank you again for the raid. Without further ado, let's just dive into this, shall we? New World Rain. Thank you for rolling on in. Thank you for the follow. Welcome, welcome. Without further ado, let's just jump into this fossil news. We'll play our fossil news stinger right here. Here we go. All right, our top story on fossil news. We've got a purported new tyrannosaur from Mexico. So let's get into that, shall we? Here's a headline from Sci News here. It's one of the very few pieces of actually mainstream news coverage I've been able to find outside of just a scientific paper. They didn't go big with the press on this one. The headline is New Tyrannosaur Species Unearthed in Mexico, Labocania aguilinae. Paleontologists have announced the discovery of a new species in the tyrannosaurid dinosaur genus Labocania, based on a partial skeleton found in Coahuila, Mexico. There's going to be a lot to discuss here, so buckle in, folks. And New World Rain says, oh wow, a paleo stream. Been a fan of dinosaurs for years? You're in the right place. Welcome, welcome. It's good to have you here. Just a little intro. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch doing some science outreach. This is literally how I make my living as a paleontologist. It's hard to find employment as a fossil scientist nowadays. There's very few jobs out there, but this is what I do full time. This is how I make my living. So it's good to have you here. And Murph, thank you for gifting New World Rain. I appreciate that. Just as the ad said in, thank you, Murph. I appreciate that. And hey, Nerduino, how are you doing? Hello, hello, welcome back. Can we get a shout out for Nerduino real quick? A fellow scientist here on Twitch. Does astronomy streams. Check him out. Let's get into this. So, this is going to be an interesting and complicated discussion today because one of the authors on this paper is somebody that I've worked with in the past. I did fieldwork with him. You might remember him from our streams, not this past summer, but the summer before. Nicholas Longrich is a fellow dinosaur paleontologist. And, yeah, he and I don't necessarily agree on a lot of things. In science, sometimes you have differences of perspective, differences of opinion, different ways to interpret certain data. And I think that notion, that idea is going to come across in spades on today's stream. So, yeah. Be cool, Theo says, I had no idea you could use this platform for good. What do you mean? There's all kinds of awesome channels here on Twitch. People doing all kinds of important stuff, charity work and news and animal conservation and science. Just browse through the science and technology category one of these days and you'll see some of those cool streams. We've got a number of scientists who stream here on Twitch. This is how we do science outreach. So, yeah. Turns out this platform is phenomenal as a means of reaching new audiences and getting people excited about the natural world, getting people excited about science, about learning. That's what I'm all about. I'm glad you're here. Welcome, welcome. Be cool, Theo. Yeah. Anywho. Yeah. The newly discovered dinosaur species lived in what is now Mexico during the Campanian stage of the Cretaceous period some 72.5 million years ago. Named Laboconia aguilinae, the ancient predator was at least 6.3 meters or 21 feet in length, relatively small by Tyrannosaur standards. Maybe because it wasn't full grown, but, yeah. Tyrannosaurs dominated as apex predators in the late Cretaceous of Western North America, Laramidia, said Dr. Hector Rivera Silva of the Museo del Desierto and Dr. Nicholas Longrich from the University of Bath. So just as another bit of background here real quick, let me reintroduce you all to Nick Longrich. You may or may not remember him if you tuned into last summer's Fieldwork streams. There we go.
Really, really neat. Maybe we should talk a little bit about, like, there are bits...
There we go.
DeVille.
Exactly.
Very nice. You got that thinned down beautifully.
Oh, yeah.
So there's Nick right there.
In there too. Nicely
in
done.
The brown felt hat.
Absolutely. Yeah. You guys want to introduce yourselves real quick?
Yeah, I'm Dr. Nick Longrich. I'm a senior lecturer in evolutionary biology and paleontology at the University of Bath.
Yeah.
Terrence Cook, just here helping out.
Nice.
Seth Cook, also a volunteer here.
Yeah,
they're brothers, those two.
Awesome.
We got down pretty far into here, and we started getting to a lot of roots, so we slowed down here, and then just...
So this is a ceratopsian horned dinosaur that we were digging up, not this past summer, but the summer before, summer of 2023, in Wyoming. New species of horned dinosaur we're very excited about. Yeah.
Yeah, it might not be the bone. It might just be kind of like an iron oxide rind over the bone. But we just we hit that, and we're going to kind of not really much point in going too much further. Just we've got most of the weight out here, and as far as exposing the bone, that's probably best done in the prep lab. So we've kind of
not going to field prep this thing.
Get this thing light enough to move.
Very nice. It's so much thinner, and I'm sure so much lighter than it was before.
Yeah.
Holy cow. Yeah.
We want to.
Here, we'll scoot forward a little bit. I wonder if Nick talks about his background.
73 million years now. Here it is being streamed on social media.
Pretty awesome.
Yeah.
Let's see. I think we've got some questions.
Anywho, there's Nick Longrich right there. How to say this? In fossil science, in paleontology, sometimes we have strong differences of opinion, differences in philosophy, different ways that we look at data, and I think it's a testament to how robust the science is that we can have very strong disagreements about things. Scientifically, socially, politically, that kind of thing, and still get along as colleagues. It's kind of the situation here. In terms of science in particular, sometimes you have wildly divergent views. And this is really... It's specific issues that we might have differences of opinion on within the science. Lumping versus splitting, you know, are we looking at true diversity of species here, or are we just looking at variation within a species? That kind of thing. Yeah, you're gonna hear some of that come to the fore in today's discussion. Just setting you up for that right now. Yeah. And it's healthy for the field, generating interest and funding. It's true, Scoobs, yeah. Yeah. So, Nick Longrich right here is second author on this new paper. During the Cenomanian and Turonian ages, from 100 to 89 million years ago, tyrannosaurs were relatively small, unspecialized, and low in diversity. We'll return to that. By the Campanian age, 83 million years ago, however, they had undergone a major radiation, diversifying and producing larger, more specialized forms. I don't know if I agree with that wholeheartedly. The Labocania clade dominated the southern Laramidia at a time when the north was dominated by Daspletosaurians and Albertosaurians, they added. And what does that mean, Laramidia? That almost sounds like something you'd go to the doctor's office for. Oh, Doc, I got a bad case of Laramidia. I'll explain what it means. Rachel Darling Endeavors, thank you for the 8 months.
Your dream was supported by those around you as you grew up, allowing you to maintain your dream and allow it to come to life.
That's true, Rachel.
Your passion for getting the world connected and informed through science outreach is astounding. Every single day, I'm excited to come here to learn new things that I can share with those around me. You break things down in a wonderful way that makes it easy for others to understand. You make an unforgettable impact. Thank you.
Thank you, Rachel Darling Endeavors. Holy cow, thank you for the 8 months of support. Thank you for those incredibly kind words. I don't know what to say in response, except I am grateful for the opportunity to be able to present this stuff. I'm so lucky that people find this interesting, and I will always strive to live up to those expectations and that enthusiasm and deliver the kind of science outreach that you've come to expect. Thank you, Rachel. Sincerely, thank you very, very much. Let's lay the groundwork here for talking about some of these concepts we're going to be exploring. Laramidia. What is Laramidia? Let me show you. We've got a cool little clip from James Gurney. There we go. Should be
recently
right here.
If we could take a journey back through time, what would we see? What did our world look like ages ago, during the time of the dinosaurs? The land was warmer than it is now, and the oceans were higher.
So James Gurney is an artist, if you didn't gather that. He's the creator of the Dinotopia series.
Was underwater. A warm, saltwater sea divided North America in two.
Yep. The Western Interior Seaway. And here is Laramidia.
Was a lost continent known as Laramidia.
So this is setting the stage for our discussion. Western North America at the time was like an isolated subcontinent, isolated from Appalachia in the east. Appalachia, Laramidia. So our Earth, let's say 90 million years ago, looked like this. The continents are always moving and shifting around, drifting around on their continental plates on the Earth's mantle. And there's that western interior seaway cutting North America in two. And here is Laramidia to the west. So it stretches from Canada in the north down to Mexico in the south. Our purported new dinosaur, Laboconia aguilinae, is from here in Mexico. While this inland sea is separating North America in two like that. Does that make sense? And what video were you just playing, please? Let me find it for you. It is this one right here. I highly recommend it, actually. James Gurney's How I Paint Dinosaurs. And TMK says we're going back to this after the ice melts. I mean, certain parts of the U.S. will be underwater. Coastal regions, much of Florida. If we lost a lot of the glacial ice, a lot of Florida is going to sink beneath the waves. Florida is only on average like 14 feet above sea level anyway. So you just get a few feet of sea level rise and you're going to lose a lot of Florida. Anyway, Laramidia over here. The Laboconia clade, our new dinosaur is a member of this genus, dominated southern Laramidia at a time when the north was dominated by Daspletosaurians and Albertosaurines, they added. So the idea here is that we've got what we call faunal endemism. Which is this idea that you've got different dinosaurs, different groups of different casts of dinosaur characters that kind of grade along a latitudinal gradient here. So like in the north, you've got different dinosaurs than you've got in the south. Just based on who's north and who's south. Like, different environments, you've got an entirely different cast of dinosaurs in the north than you do in the south. Different tyrannosaurs, different hadrosaurs, different ceratopsids, horned dinosaurs, etc. This is a popular idea among dinosaur paleontologists who work on Cretaceous stuff. This idea that the critters in the north are different from the critters at mid-latitudes that are different from the critters in the south. There's another idea that what we're looking at here is not actually differences north to south, but differences in time. This other idea states that our dates are not always precise enough or accurate enough to really be able to tell the whole story. That maybe you've got largely the same cast of dinosaur characters from north to south, except they're constantly changing and evolving through time. And so the reason why it looks like you've got different dinosaurs in the north and south is because we're looking at rocks of slightly different ages. The ones in the north are a little bit newer than the ones in the south. And so what we're seeing is dinosaur evolution over time, rather than just there being different dinosaurs in different north-south areas, you know? Is that making sense? I don't feel like I'm not being the most articulate about explaining this idea. Yeah. Scoop says, is convergent evolution plausible? I mean, convergent evolution is definitely a thing in general, but in this case, we know that these are members of the same families. We've got different hadrosaurs, different duck-billed dinosaurs that we found in the north and found in the south. We've got different tyrannosaurs in the north and in the south. That kind of thing. So we know it's not really convergent evolution. Convergent evolution implies that you've got unrelated species that evolve to look similar because they're living in similar niches. They've got similar evolutionary pressures exerted on them. This is not that. This is just you've got members of the same family. They're super close relatives. Does that make sense? They look similar because they are similar, you know? Yeah. Yeah. But good question, Scoobs. I appreciate it. And so they're taking distance without time difference, says Jody Fish. That's the idea. So there's ongoing debate about this. People like Nick Longrich are proponents of the faunal endemism hypothesis. This idea that at the same time you've got endemic pockets of dinosaurs that all evolved to be different. They're isolated from one another, and so they evolved to be different, like in the north and in the south. Other dinosaur paleontologists, like my old mentor Denver Fowler, would lean more toward, oh, these dinosaurs are highly mobile, they're not likely to get isolated, they're probably moving all up and down the coast all the time. What we're seeing here is time differences instead. And a lot of the dates that are out there are probably off by a little bit. And so that's kind of throwing a wrench into the works and making it look like you've got all these different dinosaurs at the same time, when in fact, these are just time differences. Dinosaurs up and down the coast are evolving, and if you sample them at different times, they're going to look different. I hope this is making sense. Yeah. And X-Man says, is it a mix of the two? Is a mix of the two likely? I'm sure there's aspects to both of these that are true. But to what extent, you know? So yeah, it's complicated. It's just one of those things that, like, modern biologists, zoologists, botanists, they don't really have to think about. Because all the animals we're looking at that are alive today, all the organisms that we're looking at that are alive today, are alive today. You've got, like, a whole axis of that graph that's missing. You don't have to worry about time. They're all alive right now, in the present. But you start looking at the fossil record, and holy cow, things get so much more complicated. Because you're also dealing with that y-axis. You're dealing with time there. And so as these animals are changing and evolving, that's another source of variation that you have to consider. It's important stuff. Yeah. Anyway, but yeah. And hang on a second. Oh, Ken says, please don't make Nick the face of faunal endemism for your audience. No, I'm just, for the purposes of this discussion, given that we're looking at one of Nick's papers, Ken, you know, there's a lot of other, that probably is the dominant view right now in dinosaur paleontology, is faunal endemism. Scott Sampson talks about this in a video of his. Let me see if I can find that. Anyway, it's good to see you, Ken. I hope you're doing well.
And
there
it
we
could
go.
be, my bias also is that dinosaurs may have had an intermediate kind of metabolism that was neither hot-blooded nor cold-blooded, but somewhere in the middle, what you might
Then we recognize
call the Goldilocks hypothesis.
Probably mostly
not too hot, not
hot-blooded.
Just right. And maybe they didn't need to eat as much, because it turns out that most of the energy...
Anyway, let's get to him talking about Laramidia here.
And there's no polar ice caps. Maybe the greatest diversity of animals and plants isn't at the poles, where it might be hotter. Maybe it's at mid-latitudes like Utah, because what we're finding is a super diverse ecosystem that lived 77 million years ago. So really interesting. So now we can go and put the dinosaurs back in it.
There we go.
Like that. But I really want to focus on North America. And if we go, we're
Laramidia over here.
6 million years ago. So once again, an age of extreme global warming, no ice caps, sea levels much higher than today, and there was a shallow sea that went all the way from the Arctic Ocean to the Gulf of Mexico.
Yep.
So North America was not one landmass, it was at least two. The one in the west.
And 3 and 4 at different times too. Yep.
And the one in the east has been named Appalachia. And there were sea monsters, giant mosasaurs, which are big lizards, and plesiosaurs, big long-necked things, swimming around in these oceans, and dinosaurs on land. And it turns out that if you want to understand the age of dinosaurs,
Tita Titanium, or is it Tita Titanium? Thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
there is no better place to look than this western landmass that we are sitting on right now,
Hylocomium says, was Appalachia named after the mountains, or were the mountains named after the landmass name? So the ancient subcontinent is definitely named after the Appalachian region. So it was only through intensive study of the geology and paleontology and everything that we recognized that this was a thing back in the Cretaceous period. So the region of Appalachia, that name came first, and then this ancient subcontinent was named after it. Does that make sense?
Which we now call Laramidia. And that's because we have fossils from this time period, what's called the late Cretaceous, the end of the age of dinosaurs.
Oh, and a Cool Island Song, Doug asks, has this different times idea been published? Yes. I think some of Denver Fowler's publications outline this. Some of his chapters of his PhD dissertation that were published. Let me see if I can find some of those. There we go. This is one of them. Revised Geochronology, Correlation, and Dinosaur Stratigraphic Ranges of the Santonian, Maastrichtian, Late Cretaceous formations of the western interior of North America. So this talks about it a good deal. And there's a wonderful supplementary information spreadsheet that goes along with this. That, I don't know, it's the best work that I've seen on this so far. Looking at these late Cretaceous dinosaur faunas and trying to correlate them in time. Seeing which ones actually line up, which ones actually have gaps in between, and then I think this might be the same paper where Denver actually corrects a bunch of dating errors. There were like simple mathematical errors that previous authors had made that like skewed some of those dates by as much as 1 million years. So it looked like certain things were the same age when they're actually not. So yeah, anyway, Sweetie Pie, how are you doing? Yeah, this is one of them, and I think there's... there might be a couple more, but that's the main one that I'm thinking of. And I wonder if we can get to the sup info here. There we go. Can't see, Sweetie Pie, you're in the way. Just try to grab. Download. There. And there we go. Come on. Yeah, this is it. Excellent.
Dinosaurs came in all shapes and sizes.
Be Cool Theo, thank you for the follow. Appreciate you clicking that follow button. I might have to zoom in here. Roll plus. It's not gonna work. This is not quite the one that I was looking for. There's another one that actually lists all these different dinosaur taxa. And it doesn't look like this is that. Oh no, maybe it is. Okay, we've got ammonites here. Baculites. Hoploscaphites. Yeah. Anywho, yeah. I'll give you a link to them. You can just find the sup info on this paper. No, stop it. Open office, don't do that. Okay, here we go. But yeah. But yeah. And Mark Melvin says, I see Nick also supports the idea of nano-tyrannus. Yeah, we'll talk about that too. We haven't gotten to it yet. Is there an issue with his histology results used as evidence? It depends on who you ask. I would argue yes. He and I had a lengthy discussion about this in 2023 before he published that paper. He published a new paper on Nanotyrannus back in January of this year, if I remember correctly. And a lot of it just kind of comes down to, like, what are your underlying assumptions? You know? Yeah. But yeah. Anywho, let's get back to our Scott Sampson talking about Laramidia here.
All the way from Mexico in the south to Alaska in the north. And all these places...
By the way, if that name sounds familiar to you, if any of you are the parents of young children, and you're familiar with the television show Dinosaur Train, you might recognize this voice from that show. The paleontologist in that, Dr. Scott, the paleontologist. That's Scott Sampson, who is a legit dinosaur paleontologist. I think he's now director of the California Academy of Sciences, but he does still occasionally publish papers in paleo. He was one of the authors on Lokiceratops this summer. So, yeah.
Are producing fossils. Most of them are on the east side of the Rockies, which is why it's so cool that we have Washington's first dinosaur on the west side of the Rockies up here. You just don't find many of those. The rocks aren't around to preserve them, or at least they're not exposed typically. But I want to focus on one part of this area, and that's the state of Utah, and a place in southern Utah.
The Kuiperowitz Formation. Anyway, so a lot of the folks from Utah, a lot of the folks who are working in the Kuiperowitz, a lot of the folks in Colorado as well, are really keen on this idea of faunal endemism. And let me see if I can find a nice explanation for this.
Diverse. And this has made us wonder about the environment that these animals were in, and that it was much like a Louisiana swamp in Utah back in the Cretaceous. And so this has got us thinking, well, maybe the world was very different back then. Maybe in a hothouse world where it's much warmer and there's no polar ice caps, maybe the greatest diversity of animals and plants isn't at the poles where it might be hotter. Maybe it's at mid-latitudes like Utah, because what we're finding is a super diverse ecosystem that lived 77 million years ago. So really interesting. So now we can go and put the dinosaurs back in it. This is a reconstruction of Cosmoceratops, that horned dinosaur with 15 horns, living in this swampy setting, kind of almost like cypress swamp.
I can see that
Dinosaur Dave.
50,000 a year has been well spent.
I really appreciate that. Holy cow.
That's almost 3 decades in a week, or something. I've been playing Satisfactory and my math brain be pudding. Ha ha ha.
Thank you, Dinosaur Dave, for the 35 months of support. Now at Tier 3. Holy cow. I really appreciate that, Dinosaur Dave. Thank you for the ongoing support. It means a lot to me. Let's keep the stream going.
And if we think now, going back to North America being split in two and Laramidia over on the west, what we are seeing is different communities of dinosaurs.
Here we go. This is exactly what I was looking for.
Latitudes.
Yeah.
At least up in Alberta and down in Utah. So we had those three hypotheses, if you remember. One was they weren't really different, they just lived at different times. The second was that there was a lot more food around, and the third hypothesis was that they didn't eat as much. Well, we can now rule out the first hypothesis. We've been able to date the rocks.
Oh boy. I know several researchers who would dispute that pretty vehemently. Yeah, so the rocks are not of the same age.
And it's what's called radiometric dating. It's little pieces of volcanic ash you can take out, and you can look at the rate of decay from one unstable form into a stable form, and compare those and get a sense of how old these rocks are. And it turns out that the rocks in Utah are the same age as some rocks in Alberta.
Yeah. Jury might still be out on that one, to put it gently.
Totally different dinosaurs. So we can rule out the hypothesis that they lived at different times. And that leaves us either with the more food or the not eating as much.
And yeah, I don't know if either of those is particularly plausible. But, yeah. Just laying the groundwork here for our discussion. Back to here. So this idea that you've got different dinosaurs living at different latitudes is called faunal endemism. So the high endemism seen in tyrannosaurids is remarkable, given that modern apex predators have large geographic ranges, and hence the diversity of carnivorous dinosaurs has been underestimated. I mean, before you go looking for an explanation for a phenomenon, I think it's usually, like, first you have to establish that the phenomenon actually exists. And I'm not necessarily convinced that this is a real thing. That you actually have high diversity of these animals. I think a lot of these guys are grossly oversplit. But yeah. And Claire Burr, thank you for reposting that. Neil was making the analogy of car design changing over the years. A 61 Mustang looks a lot like an 86 Mustang, but they are technically the same thing. Oh, they look nothing like an 86 Mustang, but they are technically the same lineage? Yeah. I've tried to come up with analogies using cars to help explain evolution, and it gets really tricky because, I don't know, you can have... It kind of breaks down at a certain point. But I like where you're going with that, Neilf. And yeah. So a big part of the dispute here is going to be talking about cladogenesis versus anagenesis. These are two different... They describe like two different modes of evolution. And in order to understand this ongoing controversy, you kind of have to understand this. Hey, watch out, sweetie pie. There we go. Anagenesis versus cladogenesis. Here we go. Oh, with dinosaurs. Beautiful. So, in evolution, creatures are changing, generation to generation. You're a little bit different from your parents, and your parents are a little bit different from their parents, your grandparents. That's evolution. It's just change from generation to generation. And so anagenesis is speciation, not specification, that's wrong. Speciation without splitting. Anyway, you just have one lineage that's slowly changing over time. Cladogenesis is where you have a split that occurs. You have a population that gets split, and you get new species that evolve from that parent species. Rather than just the same species changing over time, and then at some point you can arbitrarily say, oh, it's a new species now, I guess. So cladogenesis is where there's a split. You have a clade, two clades that are generated. Cladogenesis. A lot of the folks who are really into the faunal endemism hypothesis lean much more heavily toward cladogenesis as an explanation for dinosaur diversity. Whereas I and some other colleagues suspect that anagenesis might be the dominant mode of evolution for most dinosaurs. Cladogenesis definitely occurs. You definitely have splitting events that happen. But I and some other colleagues would argue that this is a rare and very special event. This is something that only happens once in a blue moon. And the diversity that we see of dinosaurs in the late Cretaceous of North America, a lot of this is because of anagenesis. You're just sampling different times, and so the dinosaurs look a little bit different. But they're largely the same lineages. It's pretty rare that you actually get splitting events like this, especially with critters like dinosaurs. Dinosaurs tend to be large-bodied animals. They require a lot of resources. They tend to be very mobile. It would take a lot to isolate a population of dinosaurs and have them form new clades, split like that, you know? You gotta have some big geographic barrier or something like that to really get them to do that. Especially as they're probably migrating all over the place, highly, highly mobile. getting them isolated and stuck in, you know, separated from one another long enough, they evolve in different directions long enough that they become different species is probably pretty tricky. But yeah. But yeah. And Salamander says, cladogenesis on a large scale is most easily observed after catastrophic events that free up many ecological niches. Exactly, Salamander. That's why it's got to be like almost a rare and special event. Something big has to happen to get big mobile critters to speciate, you know? There's a reason why we've got thousands upon thousands of species of bats and rodents. While these critters are very mobile, they also are very small, and you can have a lot of them in the same environment. They also have very short generational times. Like, from the time that they're first born until they reproduce, it's, like, pretty quick. It's probably like a year, or maybe less, for critters like bats. Same for rodents. Think of all the different species of mice and voles and critters like that there are. There's so many. And you can have a lot of different species in the same valley, for instance. Try that with big plant-eating dinosaurs. One valley will be able to support far fewer species of big plant-eating dinosaurs than it will a species of little mammals like mice, you know? Does that make sense? In any given environment, you're going to have a higher number of small species than large species. For instance, think about the African savanna. Out in the veldt like that, you're gonna have a bunch of different critters doing their thing. You've got one or two species, I guess if you're being generous, of elephants. And yet for smaller mammals, you get a lot more species. Just antelope. You've got how many different species living out on the African savanna? You've got impalas and geronooks, Thompson's gazelles and dik-diks, springboks and kudus and urdus and... Urdus? Is that a thing? Urdu's a language. Anyway, I don't know my antelopes well enough to really be able to give you a whole rundown of them. But holy cow, are there a whole bunch. Whereas, when you get really, really big, like the size of some of these big late Cretaceous dinosaurs, like ceratopsians, get to like elephant size, suddenly you're down to just one big species, you know? It's just kind of the pattern that we see in these critters. You take that and you combine it with ontogenetic niche partitioning, like we know a lot of dinosaurs did, and you reduce the diversity even further. We would expect to see fewer species of large dinosaur in a given environment than we would see species of large mammal in like a non-human decimated environment, you know? So yeah. But yeah. Anyway, does that make sense? And Crimson Carnotaurus is going back to the dinosaurs with hadrosaurs and ceratopsians. So many different crest, horn, and frill layouts across these groups. Yeah. Here. There's a nice example of that right here. Oh boy, no, not from Reddit. Reddit doesn't handle that format well. There we go. So here is just a smattering of Cretaceous ceratopsian dinosaur diversity. Is it true diversity, though? I would argue that diversity means that the animals are coeval. They're living at the same time, at least, if not necessarily the same place. What you're looking at here is tens of millions of years. You've got a bunch of different ceratopsians with different horn and frill shapes and stuff, but there's a lot of time represented here. Holy cow. From Zuniceratops right here up until Triceratops right there, you've got like 30 million years, right? It's a lot of time. At least 20 million years. And so many of these different critters did not live at the same time. And many of these represent members of the same lineage, I would suspect. Like Rubeosaurus and Styracosaurus, for instance. Ionosaurus and Ankylosaurus. And Pachyrhinosaurus, potentially. Members of the same lineage, it seems like. Diabloceratops and Machairoceratops. A lot of this diversity is temporal. It's time. You've got the same lineage of dinosaurs kicking out new species as you go along. You know? As these lineages are evolving over tens of millions of years, the critters are changing, and we find fossils of them and we go, wow, look at all the different shapes and sizes. You really have to consider the time, though, you know? Does that make sense? I hope so. Yeah. Several others are biostratigraphically different. Exactly, Jody Fish. Yes, that's the point I'm making. Yeah. And I don't think we'll do Metazoa today, just chatting. I've got too much to talk about. We haven't really even gotten into the paper yet. Yeah. And Scoop says, I wonder if gender expression was a thing. Oh, you're talking about, like, sexual dimorphism? The males and the females being different? Yeah. We see that in in a lot of modern animals. It's particularly pronounced in pinnipeds, seals and sea lions and walruses and etc. And in a lot of birds too. Did dinosaur male and females look different? I would say a lot of them probably did. But so far, when we look at the skeletons of dinosaurs, we've been pretty much completely incapable of telling males from females, unless you cut open the bones and look at medullary tissue inside. Here, I'll show you a clip. There we go.
Well, not really. I mean, get a chance to see inside.
He shipped the bone fragments that fell out to
So these are bone fragments that fell out of a Tyrannosaurus femur, thigh bone of a T-Rex.
Mary Schweitzer.
So the first piece I pulled out, I picked it up and I looked at it and I said, it's a girl and it's pregnant.
Is the absolute prerequisite to the evolution
And
of large mammals.
G-Class, thank you for the follow. Welcome, welcome. Let me rewind that, because it is a real, a real kind of a moment here. What was it? There we go. That's the sound effect I was looking for.
Fragments that fell out to Mary Schweitzer.
So the first piece I pulled out, I picked it up and I looked at it and I said, it's a girl and it's pregnant.
Yep.
That's the first time, as I understand it, that anyone had ever been able to identify gender in any dinosaur.
Yes.
Mary recognized a specific type of bone called medullary bone, which female birds produce when they're about to lay eggs.
Yeah, so it's kind of funny that Leslie Stahl said gender, the journalist. We're not talking about dinosaurs didn't have gender. Gender is like a human construct. It's like a social thing. Biological sex is what she's talking about. which itself doesn't necessarily have to be binary. We think it probably was in dinosaurs, probably. But anyway, it's been like impossible to tell if a dinosaur was male or female unless you cut open the bones and look for medullary tissue inside, which only occurs if the dinosaur is A, female, and B, pregnant.
Medullary bone, which female birds produce when they're about to lay eggs.
Yep.
No one had ever found it before in a dinosaur. It was yet another link to birds, and it meant that B. rex was definitely no Bob.
So she calls you up and she says...
Calls up and says, we have medullary bone.
Oh, now this had to be thrilling.
Yes, very exciting. And that wasn't all.
Yeah, anyway, more cool stuff happens here too. I'll give you the link so you can watch the whole thing if you'd like to. But yeah. And Petrodactylus says, that's insane. I had no idea it was possible to tell if a dinosaur was pregnant like this. Yeah, we've been able to figure it out for a few different dinosaurs, but only if they're female and only if they're pregnant at the time of death. Only if they've got that medullary tissue inside their bones. So, we've got a test for whether or not a dinosaur is female. We don't yet have a test for whether or not a dinosaur is male, you know? You know how in Jurassic Park, how all the dinosaurs are female? At least up until a certain point? There is a slim chance, I suppose, I guess, that that's how it was during the Mesozoic, too. Maybe there only were female dinosaurs, just because we've never been able to prove that any dinosaurs were male. Not yet. There's no way to test for it yet. But yeah, and that's because the skeletons of male and female dinosaurs seem to be identical. They probably varied in size, but that's not a good indicator of whether a critter is male or female. Because you're just looking at a very big female or a smaller male or, you know, that kind of thing. So yeah. That is a potential source of variation, sexual dimorphism, but we've never been able to demonstrate that outside of the medullary bone. That's the only way that we've been able to tell if a dinosaur is female or not, I guess. Pregnant or not, and thus female. And that's not altogether surprising, because today we've got birds who sometimes they've got strong sexual dimorphism in terms of size and in terms of external appearance. They've got different feathers, different skin colors, stuff like that between males and females, different eye colors. But that stuff really doesn't fossilize, you know? The skeletons of male and female birds, identical. Except maybe in terms of size, but that's not a reliable indicator anyway. So we wouldn't really expect, I guess, when you think about it, we wouldn't expect male and female dinosaur skeletons to be different. Because they're largely identical in modern birds, which are their closest living relatives. Birds are literally living dinosaurs. You can get some subtle differences in crocodilians today, but they're more distantly related to dinosaurs, and maybe are not the best analogy for this kind of thing, you know? So yeah. Yeah. And there you go, Alexander Morrison, yeah. But yeah. Yeah. Oh yeah, and dinosaurs didn't have baculae, Charlie's Dragon, that's right. No bone within the male genitalia. So yeah. And Hylocomium says some creatures can change sex throughout their lives. A lot of creatures do that. Shoot. Do we have any theory on that for dinosaurs? We don't. We don't understand dinosaur sex enough to really be able to make any kind of strong inference there. We've got no reason to think that they could do that. We don't see that in any modern crocodilians or in any modern birds. And so we've got no reason to think that that ever evolved in dinosaurs. Maybe it did, but we don't have any reason to suspect that, if that makes sense. A lot of times when we're talking about stuff like this, trying to figure out something that's unknown for dinosaurs, we use what we call the EPB, the extant phylogenetic bracket. And it's just this. What do we know about birds? What do you know about crocs? What can we infer about that for non-bird dinosaurs. Does that make sense? We look at the closest living relatives of dinosaurs. Crocs, who are like cousins to the dinosaurs, and birds, who literally are living dinosaurs. We can use them to kind of organize our thoughts and come up with what is the most likely scenario for the non-avian dinosaurs. So yeah, does that make sense? When you're speculating wildly about dinosaurs, let birds and crocs be your guide. And Hylocomium says, why do we still have separate clades for birds and dinosaurs? We don't. No, birds are part of the dinosaur clade. Yeah. Yeah. And Gamer Girl Me says, it's really mind-blowing to even think that birds are living dinosaurs. It's really fascinating. Well, that's true. Yeah. Yeah. And wasn't signs of a throat pouch found on a Tarbosaurus specimen? I'm not familiar with that, Crimson Carnotaurus. I've not heard of that. Anyway, talking about birds and dinosaurs. Show this off again, but this is an infographic that I made. We'll be talking about this a lot next month in November, as Turkey Day approaches. El Dia del Pavo. Your turkey is a dinosaur. All birds are. Not just turkeys, but ostriches and hummingbirds and penguins and geese. Budgies and woodpeckers and cassowaries and emus. They're all dinosaurs. They evolved from earlier theropod dinosaurs, and we see evidence of that in their skeletons, and their feathers, and their respiratory system, in their behavior, and their eggs. It's a done deal. It's a general consensus now, pretty much incontrovertible, that birds are living dinosaurs. And this infographic that I put together talks about that. So feel free to download it and print it and share it with your friends and family. But again, we'll be talking a lot about this in November, in the run-up to Thanksgiving. Yeah. Lindelia says, is that why birds are so rude? Because they're cranky that they are no longer ruling the world? I mean, in a way, they are kind of ruling the world. Do you know how many living species of bird there are? It's more than twice that of living mammal species. It's, over 9,000! Yeah, it's a lot. Most estimates put it around 10,000 or higher. Yeah. Anyway, and there you go, Gravity. Yes, indeed. Yeah. But yeah. Yeah. And Scorch Hellfire says, so it's a false distinction between modern birds and reptiles? Yes, Scorch Hellfire, yes. I'm so glad you asked that. Birds are a kind of reptile. Talk to any ornithologist, any herpetologist, any paleontologist, any evolutionary biologist, any zoologist, they'll tell you. Birds are part of what we call Sauropsida. I'll show you on the old Tree of Life here. Jump to amniotes, which are our vertebrate animals that lay eggs on land. There we go. Amniotes are land-living, or ancestrally land-living vertebrate animals lay shelled eggs on land. And so, from amniota, you've got two branches that come off, the mammals and the sauropsids, aka reptiles. This includes birds, squamates like modern lizards and snakes, crocs and turtles. They're all sauropsids. Birds, turtles, and crocodilians, and dinosaurs too, belong to a group called Archaeolosauria. And then Archosauria, more specifically. This is crocs, dinosaurs, and birds belong to this group, Archosauria. So, a bird is more closely related... Oh, here, I'll put it this way. This Nile crocodile right here is much more closely related to this black-headed bunting, well, this golden-tailed sapphire hummingbird, or this black-headed gull than it is to a lizard. Crocs are closer to birds than they are to lizards. Pretty cool, right? Yeah. Yeah, Archosauria, the ruling reptiles. Yes, indeed, Alexander Morrison. Yeah. So we know this from fossil evidence. We know this from DNA evidence. It's, this is not disputed. This is the scientific consensus. It'd be very difficult to find somebody who would argue with this. You'd have to find somebody who, like, doesn't believe in evolution. Or someone who thinks that the Earth is flat or something like that, you know? Like, this is the scientific consensus, you know? So, yeah. The science be settled here. There you go, Alexander Morrison. Yes. Yeah. So, yeah. And are cats closer to birds or lizards? They're equally distant to both of them, Panda Sam. That's a great question. Here, let's jump from birds and crocs, Archosauria, dinosaurs too, down to where cats are. Cats are a kind of mammal. So, yeah, and let's jump to cats. They're within carnivora. There you go. There's your cats. And cats are a kind of mammal. Oh, whoops. No, not tour. Sorry, I did that wrong. There we go. Mammalia. Yeah. So, both birds and lizards are sauropsids over here. So, cats are from a totally different branch. Mammalia over here. Does that make sense? Yeah. Anyway. Good stuff. And Euphoria Liquid says... A euphoric liquid says, I learned something and my brain doesn't even hurt. I'm happy to hear that. That's what we're here for. That's what we're all about here, you know? Oh, yeah. Anywho. We don't have dinosaurs on this tree, or we do have birds. Birds are the only dinosaurs we have on this tree. Up here. Because this tree only really focuses on living animals. Although, who knows, that might be changing in the near-ish future. I gotta talk to these good folks about that because, let me check that email right now before I forget. There we go. And...
Let's protect our fossils.
Ra Logal.
If they're removed,
thank you for the
America
prime.
loses them forever.
I really appreciate that, Ra Logal. Thank you for the prime sub there. Thanks for supporting science outreach here on Twitch. I appreciate it. Good stuff. Yeah. I'm gonna talk to the One Zoom folks and we might actually get non-bird dinosaurs added. Which would be super cool. And Catatoon, thank you for gifting Deshara Fernando. I appreciate that, Catatoon. Thank you, thank you. Good stuff. Dashare says, best channel on Twitch? You flatter me. My goodness. Thank you, Dashare. I appreciate you. I don't know what to say. Good stuff. Holy cow. Yeah. Shoot, all that being said, we need to talk about our new Tyrannosaur. Let's get back to that, shall we? I know a bunch of people have come in since then, so let's get back to this. Newly published just last week, a purported new species of Tyrannosaur from Mexico. Labocania aguilinae. see it walking along the shores of Laramidia right there. The Tyrannosaur species unearthed in Mexico. The highly fragmentary and weathered partial skeleton of Labocania aguilinae was found in the upper part of the Cerro de Pueblo Formation at La Parita, 54 kilometers west of Saltillo, Coahuila, Mexico. The dinosaur's anatomy suggests it represents a Tyrannosaurine with affinities with Teratophoniinae, specifically Labocania anomala. So that is a dinosaur that was described back in the 70s, I think, by Ralph Molnar, which probably represents a tyrannosaur from Mexico. Labocania aguilinae is closely related to Labocania anomala and Bistahyver cercilii and Teratophonius currii, the paleontologist said. It adds to the diversity of the Cerro de Pueblo Formation.
Observation. You couldn't see a thing. Conclusion. Dinosaurs.
Thank you, Albatra, for the 3 months of support. I appreciate that. It shows that endemicity existed within tyrannosaurs in the late Campanian, with distinct species and clades inhabiting the northern Great Plains in the north and the American Southwest and Mexico in the south. Given the limited geographic sampling, many tyrannosaur species likely remain undiscovered. This is some interesting stuff.
Really spectacular.
And thank you, Catatoon, for gifting Gamer Girl Me. I appreciate that.
One sub to Gamer Girl Me.
Thank you, thank you. I don't agree with everything in this paper. And you know what? I very well might be wrong about this. Shoot, I probably am. But I'm going to walk you through it, and we'll talk about why this is interesting, and why it's important to discuss this kind of thing when we're talking about dinosaur paleobiology. Why large dinosaurs seem to have had such unusually high levels of endemism compared to modern mammals remains unclear, the author said, and that sounds very much like Nick Longridge there. I would suspect, based on what we know about the paleobiology, especially the ontogeny of non-avian dinosaurs, you would expect their diversity to be lower than modern mammals. So what's going on here? The discovery is described in a paper published this week in the journal Fossil Studies. We'll take a look at it here. And this is, of course, open access, so I will give you a link right there. And there is no paywall for this paper, which you gotta love. Open to the public.
Access granted.
So if you'd like to follow along at home, you can download the paper and read along with me. Right there. Softy NB, how are you doing? Hello, hello. Welcome to Paleontologizing. And endemism. Yeah, so Softy NB, this is what we were talking about before. Let me, for those of you who are just joining us. There. Scoot back just a bit. There we go.
Wonder about the environment that these animals were in, and that it really
Scott
is
Sampson
much
here
like
talking about this.
a Louisiana swamp in Utah back in the Cretaceous. And so this has got us thinking, well, maybe the world was very different back then. Maybe in a hothouse world where it's much warmer and there's no polar ice caps, maybe the greatest diversity of animals and plants isn't at the poles.
Is it here?
This is the kind of thing you would have seen looking out your window.
There we go.
A house on the coast of Laramidia 77 million years ago. Now, starting in the 1960s, paleontologists began to notice that the dinosaurs they
Here we
found
go.
all the way from Alberta down to Texas were the same groups of dinosaurs. They
Same
always
families.
found tyrannosaurs and horned dinosaurs and duckbills, etc. But they appeared to belong to different species, different organisms at the species level. So it's like having different kinds of birds or different kinds of big mammals, you know, like a black rhino and a white rhino, for example. But the strange thing was that everywhere we looked, there were different species. So same groups, but different kinds at that lower level, which was very weird because you have to remember that Laramidia is only about 1/5 the size of present-day North America.
Yep.
And
not a lot of land.
It appeared that there were
grand
well
scheme of
over
things.
24 giant animals, well over 1,000 kilograms. Now compare that today with
2,200
Africa,
pounds.
where we think of the big animals living. There's only about 5 species of animals in Africa that exceed 1,000 kilograms, things like elephants and giraffes and rhinos and hippos. Only 5, covering the whole continent.
Yep.
Now we're talking about an area that's 1/5 the size that has well over 24 giant animals. And there's a good reason why there's not so many today in Africa. Some may have been wiped out by us, but there's other reasons, and it has to do with making a living. There has to be enough food to support all those different species if they're going to persist over a long period of time. So when I started working in Utah, there was a mystery to be solved. And that mystery was this: how could so many different kinds of giant animals live together on such a small chunk of land, a little bit of real estate?
Little Pink Pony says, but are they really different species? Little Pink Pony. I like where your head's at there. Maybe they're not. Maybe it's a little bit more complicated than that. Huh?
And when we thought about it, we really could come up with only 3 reasons to explain how you could have different dinosaurs living in Montana and Utah. Why wouldn't they be the same ones? And our 3 reasons were, these 3 possible solutions were, the dinosaurs maybe didn't coexist. Maybe they lived at different times.
I have some colleagues who suspect that this is the answer. That the dating methods that we have are not precise enough, and sometimes there have been errors introduced so that we get the wrong dates. Things seem like they're the same time when they're actually a little bit offset. So you've got time for evolution in between those. So the reason why the dinosaurs in Montana look different from the dinosaurs in Utah is because you're looking at different times. The creatures have evolved since then. That's why they look different. This is the answer that I lean toward.
Ontogeny.
Ontogeny is definitely part of it as well. Gravity, yes. But yeah, Jody Fierce, chronostratigraphic distance, exactly. Yeah. But, yeah. And Crimson Carnotaurus, yes, but that's kind of getting into the same idea too. That idea of anagenesis, Crimson Carnotaurus, but yeah. But yeah.
Remember, we think in these very short time frames, maybe these dinosaurs appear different just because we're sampling periods that are millions of years apart. And maybe if we could really sample the same time periods, we would find that they would be exactly the same animals north and south on Laramidia.
I suspect that with further work, that's what we're going to see. And some of the dates that people relied on in the past are definitely wrong. Like, they've been demonstrated to be wrong. And it's kind of shocking just how long it's taken. Some people are still not going with the revised dates. They're just kind of pretending that this didn't happen. But, yeah.
So that was one hypothesis to be tested. The second hypothesis is that there was just a whole lot more food around back then to support all these different dinosaurs. And the third hypothesis is that the dinosaurs didn't eat as much to make a living. So if they don't have to consume as much food, maybe there could be more species around. And you have to...
I don't think that's true at all. We have lots and lots of evidence that dinosaurs had elevated metabolisms. In many, many cases, you know, they would have been more warm-blooded than mammals today. Would have required more food. Yeah.
Remember, dinosaurs are reptiles, and reptiles today are cold-blooded. And
not all reptiles. Birds are not, obviously.
If you think about cold-blooded versus warm-blooded animals, reptiles are like the Toyota Priuses of the animal world. They don't need to eat very often. A crocodile can eat a meal and then not eat again for weeks. A lion of the same size eats and then has to eat again within a few days. So
I like the Prius analogy. It's true. I don't have to fuel up my car very often. I drive a Prius, and that thing kicks butt. Holy cow. Best field vehicle I've ever owned. But yeah.
Mammals, like us, we're the gas-guzzling SUVs of the animal world. We have to
but so are birds.
Consume a lot of food to keep
and
our internal
most dinosaurs
flames,
too.
internal fires stoked. So, which were dinosaurs? We don't know.
So this talk at the Burke Museum by Scott Sampson was 8 years ago. We've got a general consensus nowadays that most, if not all, dinosaurs had elevated metabolisms. They were more or less warm-blooded. Yeah, we know they grew extremely quickly when they were young. We know they consumed a tremendous amount of food. We know they lived fast and died young. That's characteristic of an endothermic animal. Creature that's warm-blooded. You know? Yeah. And Euphoric Liquid says, aren't birds way more calorie-consuming than other things of that size? Hummingbirds in particular, yes. Hummingbirds consume their own body weight, like, every day. Their own body weight in food. It's nuts. They've got a crazy high metabolism. Different birds have got different metabolisms, but they are consistently high. They require a lot of food. So that old phrase like, oh, you know, you don't eat very much. You eat like a bird. That's not what that means. If you eat like a bird, it means you eat a lot. You might consume your own body weight every day in food. So yeah, birds famously eat a lot of food, even if the old saying kind of obscures that. But yeah. And were the bigger dinosaurs herbivores or carnivores? Oh, the biggest dinosaurs of all were the sauropods, which were herbivores. So critters like Paralotitan right here. Oh, sorry, not Paralotitan. Patagotitan is who I'm looking for. Even bigger. One of the biggest creatures to ever walk the Earth. It's a creature like the size of a jetliner. Enormous. They eat plants. Significantly bigger than most blue whales. It's an enormous creature. Just gargantuan. So there's Patagotitan compared to a T-Rex and an African elephant. It's big. The very biggest dinosaurs were all plant eaters. If that makes sense. And it's amazing they could get so big. They would have to eat so much. Well, they did. Sauropods like this, like Patagotitan and its relatives, these big, long-necked, plant-eating dinosaurs, they had a few aces up their sleeve. One of them is that they laid relatively small eggs. And so they could replenish their population relatively quickly if they had like a big population crash. Unlike a blue whale, or any other kind of whale that has to have like a massive calf once every few years, these guys could have dozens of young every single year. And then that allows the rest of their body to get extra big too, because they don't have to expend all of that that calorific energy and stuff like that in producing giant offspring. They just produce these little eggs. So they can grow really large, partly as a result of that. They're also extremely efficient in the way that they moved around. That long neck would have allowed them to browse on treetops or browse at ground level height without having to move their body very much. They could swing that big neck around without even having to take a step, feed in a gigantic arc. So access all of this vegetation while standing still. Very, very efficient. Likewise, they didn't chew their food. They would have been able to just ingest massive quantities of vegetation very quickly. Just inhaling that stuff, swallowing it whole, and having their guts just break it down and digest it. Because they had these enormous barrel-like guts. Huge torso with just a massive length of intestine and stomach and everything else in there for just fermenting this plant material. So by not having to take the time to chew, they didn't have to spend as much of their time eating as, say, a cow or an elephant or something like that. They would have been much more efficient, much faster at consuming large quantities of vegetation. Does that make sense? That and a number of other things, elevated metabolism, being warm-blooded, would have helped these guys reach tremendous sizes. I mean, just gargantuan. Yeah. May I hire one to get my lawn done? There you go, Gravity, yeah. Well, it might knock over your house, too, but... Yeah. And Kleber says they don't eat grass. There wasn't any grass back then, so that's a good point, too. Yeah. And would any big carnivore try to mess with that thing? The biggest of the sauropod dinosaurs were probably too big to really be hassled by predators. Yeah. Large size would have been a defense against all but the most aggressive or foolhardy of big theropods. There were, big carcharodontosaurs for a while in South America. Would potentially go after these guys, but like predators today, you're not going to have a lion going after a full-grown elephant. You know, a lion might try and tackle a baby elephant who's young and inexperienced and small and not as strong. It's probably the same with these guys. I don't think anybody would be touching the biggest of the sauropods. Because they were huge. Just one blow from the tail, just vaporize you or me, you know? Completely wreck us. Do a maybe fatal damage to even a Giganotosaurus or something, one of these big carcharodontosaurs. So yeah. The biggest of the sauropods probably didn't have to worry about getting eaten by predators unless they were super old or sick or weak or like that. We also have evidence that these guys, many sauropods lived in herds too. They were very social animals. We've got evidence of that from trackways and from mass death assemblages and stuff like that. We've got good evidence that these guys were social. They lived in groups. They took care after each other. They looked after each other, rather. So, yeah. But yeah. And Dashir says the way a T-Rex would not go for an adult trike. Yeah, it wouldn't be its first choice. Yeah. Yeah. But yeah, anywho. Let's get back to this.
My guess is we're going to know for pretty certain within the next couple of years, and I have strong biases about it, but we haven't been able to demonstrate it for sure one way or the other. So keep these ideas in mind. Either the dinosaurs lived at different times, there was more food, or they didn't eat as much, and as ideas to explain how you get so many giants on one chunk of land.
A small chunk of land, too, in the grand scheme of things. Now, this is brought up in the press release for our new Tyrannosaur. Why large dinosaurs seem to have had such unusually high levels of endemism. Endemism means that you get different species of dinosaur living in, like, different geographic areas. Rose the Mantis, thank you for the follow. Welcome, welcome. Why large dinosaurs seem to have had such unusually high levels of endemism compared to modern mammals remains unclear. I don't think it's that unclear. I just don't think they had that. I think a lot of this is temporal, and a lot of this is oversplitting. But let's get into the paper, shall we? Here it is. Again, if you would like a link, that's the paper right there. And could they have learned to farm their own food after all ants do? we don't have any evidence that dinosaurs were farmers. They wouldn't have needed to be, you know? These are big mobile animals. They can move to where the food is. That kind of thing. Yeah. They could travel many more miles in a day than your typical ant. I'll put it that way. So the title in the journal Fossil Studies, which is kind of a new journal. I think Nick Longarch might actually be one of the... He might be chief editor of this journal. It's interesting that he's publishing in it. Anyway, a new tyrant dinosaur from the late Campanian of Mexico reveals a tribe of southern tyrannosaurs. Interesting. The end of the Cretaceous, the abstract starts. The abstract basically is like a short summary of the paper. And here, before we get into this, let me just say, brief disclaimer, we're about to dive into a scientific paper here. This might be new for a lot of folks. I do not want you to be intimidated by this. You know, this is how we as scientists communicate ideas to each other. And, well, mostly to each other. If we want to communicate ideas to the general public, we'll do a press release. You know, like you saw right here in Sci News. This is for the, you know, general public consumption. But this right here is the real deal. This is the original scientific publication. There's going to be a lot of jargon in here. There's going to be a lot of terms that are going to need explaining, but that's why I'm here. I feel like most folks in the general public never get the chance to really take a look at a scientific paper. You probably hear about new scientific findings on the news and stuff like that. Oh, scientists have just reported this and that in a new study. This is one of those studies. We're going to dive into it together. So don't be intimidated. I'll break it down for you. And if you've got any questions, don't be shy about those. Just type them right into the chat. All right? Salamander says, I love getting to go through the scientific papers on stream. Thanks, Salamander. Me too. This is one of my favorite parts of streaming, for sure. So the abstract here is just a short summary of the paper. The way that I usually describe it is, imagine it's like a movie trailer. It tells you what the movie is about, except it's also full of spoilers. So this is a movie trailer that also gives away the ending to the movie. It's the abstract. So it starts, the end of the Cretaceous period saw the western interior seaway divide North America in two landmasses, Laramidia in the west and Appalachia in the east. We know that already, but I'll show you. Back to 90 million years ago. There we go. Appalachia in the east, Laramidia in the west, and that interior seaway subdividing them. This is what we're talking about here. So Laramidia is our lost continent here. This is what we're talking about. And you saw this in Scott Sampson's presentation here too. Come on. There we go. Laramidia, Appalachia. Laramidian dinosaurs inhabited a narrow strip of land extending from Mexico to Alaska. Mexico to Alaska. Laramidia. You got it? Within this geographically restricted area, dinosaurs evolved high diversity and endemism, with distinct species in the north and south. I don't necessarily agree with that. I don't know if it's really endemism, but we'll continue. Here we report a new tyrannosaurid from the late Campanian age Cerro de Pueblo Formation of Coahuila, Mexico, which is part of a tribe of tyrannosaurs originating in southern Laramidia. I don't think we necessarily know that for a fact either, but okay. Phylogenetic analysis recovers the new tyrannosaur as part of the clade including Labocania anomala from the La Bocana Roja Formation of Baja California Norte, plus Bistahiversor and Tyrannophonius and Dynamoterror. So, computer analysis of these different critters, their different characteristics, can spit out a family tree for us. And that family tree that they've generated shows that this new Tyrannosaur comes out next to these other Tyrannosaurs that were found in the past. Do a brief digression. Let's talk about cladistics real quick. And let me explain that concept. I know we've looked at this before, but we've got some new folks here. Let's talk about what that is, cladistics.
The method is called cladistics.
There we
go. A systematic approach to sorting out relationships based on shared characteristics.
So when we're trying to classify living things, or now extinct things too, in the form of fossil organisms, you know, you can say this one looks more similar to that one, they've got similar vibes, they look very similar, that kind of thing. But that's not necessarily the most scientific way to go about things. A way to actually put numbers on it, a way to try and do it in a more or less quantitative way, based on numbers, is cladistics. This is how it works.
These animals are more closely related to each other than any of them are to the dragonfly, because they all have backbones, and the dragonfly does not.
Yep.
These three are more closely related to each other than to the fish, because they all have 4 bony limbs.
So these are different characteristics.
Only they have feathers.
Feathers are an important character. A character is like a trait. It's a characteristic. It's a feature of these critters that's informative, you know? And certain characters are better than other ones. The presence or absence of feathers is a very informative characteristic. Today, only birds have feathers. You're not going to find feathers on fish or mammals or insects. They're only on birds. So that's a very informative character. A bad character would be like color. Like, oh, I'm just going to put all the yellow animals together. Like, that's going to lead you astray. It's not going to go well. It's a bad character, you know? So choosing which characters are, like, selecting good characters and only using those in your analysis is crucially important. Or feathers on Elton John. Well, there you go, Frozen Obscurity, but he took those from birds. Yeah. How far is a grasshopper wing from a feather? Very far, euphoric liquid. Yeah. They're not similar at all, really. Yeah.
The results are plotted on a branching diagram called a cladogram.
Yep. And so here, presence or absence of wings would also be a bad character, because dragonflies have wings and birds have wings. But those wings are super different. Bird wings are made out of arm bones and muscles and feathers. Insect wings are made from chitinous exoskeleton and various like membrane-y stuff. And I don't know enough about insect wings to really explain them well, but I do know that they're very, very different from bird wings. So color or presence of absence of wings, not good characters. But stuff like presence or absence of novel structures like feathers, or maybe number of digits on your fingers, or stuff like that. Stuff that is actually informative. Those are good characters.
Most of the features that you have are inherited from very distant
Gautier talking about this.
And only a few features are really unique to you. And if we wanted to find you plus your descendants, we'd have to use those unique features that arose just with you and are carried on by your descendants, and not the features that you inherited from very distant ancestors. You wouldn't want to say you're related to an ape because both of us have 5 fingers, because, gee, so does a lizard, so does a turtle. All right? You'd want to say that we're related to the great apes because we both lack tails, and we're big.
To find the closest relative of birds, Gautier programs his computer with hundreds of characters that, in his judgment, are found in modern birds, Archaeopteryx, dinosaurs, and various reptiles. The computer then sorts through all the evidence supplied by Gautier to determine who's most closely related to whom.
And there it is.
The computer says that Archaeopteryx's closest relative was Deinonychus, which was itself derived from other dinosaurs.
So we're going to see this in the paper, and this is crucially important to understand. I'm so glad that we were able to find this clip and talk about it here. This is a cladogram. This is an evolutionary family tree, but it's kind of a hypothesis in a way, you know? It's like it's a garbage in, garbage out kind of a scenario. So, like, if you put bad characters in, you're going to get a bad result. So that's important to understand here. that making sense? So, a phylogenetic analysis, so a cladogram like that kind of analysis, recovers the new Tyrannosaur as part of a clade, part of an evolutionary group, including the dinosaurs Laboconia anomala, Bistahyversor celii, Teratophonius curii, and Dynamoterror dynastes. Distinct frontal morphology. The frontal is one of the bones in the forehead. So the shape of that forehead bone and the younger age support recognition of a new Tyrannosaur as a distinct species of Laboconia. Laboconia aguilinae. So they're saying this looks similar to another dinosaur from Mexico, but since it's a little bit younger in age, they're going to give it a new name. And you know what? I'm okay with that. You know, if it is stratigraphically separated, then that makes me much more comfortable about saying that it's a new species. Sure. It's different. Like, it makes sense that it would be different, but does a specimen this fragmentary deserve a brand new name, though? We're talking about that. So the Laboconia clade, so this evolutionary group of dinosaurs, this very specific group, it just includes these two species now. They dominated southern Laramidia at a time when the north was dominated by Daspletosaurines and Albertosaurides. To me, that's a big leap, given that even the original Laboconia material is also very, very fragmentary. So, I don't know. The high endemism seen in Tyrannosaurs, so like, that you get so many different species at different latitudes at the same time? I don't know if I buy that argument. But they're saying that it's the high endemism, that idea, is remarkable, given that modern apex predators have large geographic ranges, and hence the diversity of carnivorous dinosaurs has been underestimated. I disagree strongly with this. But that's my bias there, you know? I think that the diversity of these dinosaurs has been overstated. I don't think there's nearly as many as a lot of people claim. I think that people see the differences rather than looking at the similarities. To grossly oversimplify things here. It's a difference in philosophy, ultimately. Is your first assumption that you're looking at biodiversity? Or could it be that you're just going to have a lot of variation within a single species, you know? So yeah. Salamander says if stratigraphic separation is significant enough to assume that distinct morphological or ecological change has taken place, what would your solution be instead of naming new species within the existing genus? That's a good question, Salamander. There is kind of a thing where everybody wants to name new species, or especially new genera. I think if you're really concerned with just, you know, gotta catch them all, gotta name as many new species as I can, and like, I guess go ahead and name a new species, but I've always really admired the approach where it's like, yeah, here's something that's new and interesting, potentially new, but interesting. We're gonna publish on it, and we're just not gonna give it a name. We're gonna call it the Coahuila Tyrannosaur. Just not give it a scientific name. Wait until better material comes along, you know? This stuff is scrappy, fragmentary as this. Does it really warrant a new name? No, that's like a judgment call there, and my judgment call would probably be, let's not name it, you know? But yeah. Joyce Lee Music, it was great seeing you at TwitchCon as well. How are you doing, Joyce? Hello, hello. Am I following you yet, Joyce? Let me make sure that I do that.
This is it. This is
hang
the
on a second.
Which marks the extinction of the dinosaurs. Below this level, and out in
DJ
here,
Shark
there are dinosaur
Girl.
fossils. Above this level, on these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
Hello, hello, DJ Shark Girl.
And then 8 raiders have stumbled below that level.
How are you doing? Welcome to Paleontologizing. It's good to have you here, DJ Shark Girl. How did your stream go? Did you do some music? Very nice. Kingdom Hearts HD 1.5 plus 2.5 remix. DJ Shark Girl, I hope it was fun. It's good to have you here. Welcome. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. We're talking about a purported new tyrannosaur. Just published a few days ago. We're going through the original scientific paper and talking about it. Some good discussion today, you know? I don't necessarily agree with a lot of these findings, but those differences there are good fodder for conversation, for talking about these scientific concepts, so it's good stuff. Yeah. And, but yeah. And stream was good, played Disney game, very nice. I hope it was a ton of fun, DJ Shark Girl. Thank you for joining us. Good stuff. It's not every day that a new dinosaur species gets announced. It's about once every 7 days this year. Let me walk you through that, actually. So far, in the year 2024, let me show you the new dinosaur genera and species that have been named. Oh, hang on. Urgle Wurgle, thank you for those 10 gift subs there. Extraordinary. Thank you very, very much for the support, Urgle Wurgle. Fantastic. Lovely Tinamu Bird here, very excited about those gift subs. Oh, shoot.
Urgle Wurgle is overloading the system with 10 gift subs.
Thank you, Urgle Wurgle. Don't worry about the Tinamu Bird, he'll be fine. There's 10 people in the chat who won't have to worry about any ads for the whole next month, thanks to you, Urgle Wurgle. I appreciate you. Thank you. Good stuff. Good stuff. Here, let me show you this. The number of new dinosaurs that we have so far just this year. We've got Alpakakush. This is in alphabetical order. We've got 1, 2, 3, 4, 5, 6 with Chakisaurus. 7, 8, 9, 10 with Diukin. 11, 12, 13, 14, 15 with Herendraco. 16, 17, 18, 19, 20, 21, 22, 23, 24 with Mincaria. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 with Udulara Titan, 37, 38, 39. 39 new dinosaurs published just in the year 2024 so far. 39. Did I say 39? How many weeks are we into 2024? It's currently week 40. Okay, so we're one off from it being one new dinosaur every week so far. That's nuts. So on average, that's like once every 8 days? Less than that? New dinosaur has been published just this year. Incredible. That's awesome. That's really, really good. And we're only at the beginning of October so far. And the week is not over yet. It's true, Analog Clock. It's true. So we'll say, yeah, on average, once every week during the year 2024, we've had a new dinosaur published, on average. We've gone over every single one so far, as of today. And I'm excited about that. This is actually one of my presentations at the, I'll be talking about this at the Society of Vertebrate Paleontology meeting, our big annual conference for vertebrate paleontologists. In Minneapolis this year, one of my presentations is on this, and it's good stuff. I don't know, I'm excited. Anyway, 0.975 dinosaurs per week. Thank you, Salamander. Yes. So anyway, DJ Shark Girl, there's new dinosaurs being published all the time. It's one every 9 days on average for the past decade. So from 2014 to 2024, on average, once every 9 days, there's a new dinosaur published in the scientific literature. One of those is right here. Labocania aguilinae. So this purported new Tyrannosaur it's from right down here in Mexico. I love that they show you the Western Interior Seaway, Appalachia, and Laramidia. This is, for anybody who just waltzed in, what North America looked like about 90 million years ago. Or during the late Cretaceous, at least. Yeah. All these Midwest states were underwater at the time, including most of Texas. Florida, much of California, Oregon, Washington. Sea levels were higher back then. And our new dinosaurs from this coastal region right here. And it is from... oh boy. They don't have great strat on this. They're saying just the upper part of the Cerro de Pueblo Formation. It would be nice to have actual dates on this, you know? That's pretty vague. But whatever. The specimen was dug up, like, 20 years ago. Here we go. Labocania aguilinae. The species name, aguilinae, honors Martha C. Aguillon, discoverer of the specimen and a long-time career paleontologist of Coahuila in Mexico. And so here's the actual material we're talking about. When it says holotype right here, the holotype is the original specimen that the whole species is based on. So the original, the OG specimen here. CPC 2974 is the specimen number. It consists of fragments of the maxilla. The maxilla is the upper jawbone, tooth-bearing bone in the skull. We've got a fragment of that. We've got left and right frontals, so 2 little bones from the forehead. The ventral part of the left lacrimal, so the lower part of the bone near the eye. Partial nasals. Nasals, as you would imagine, are near the nose. So yeah, partial nasals, not complete. The posterior, the back end of the left squamosal. It's one of the bones from the back of the head. Fragments of 2 cervical vertebrae. So you've got bits of 2 neck bones. A dorsal centrum. So that's the center of one of the back vertebrae. Fragments of the sacrum. So those are the vertebrae inside the hips. We've got fragments of those. The posterior end, the back part, of 2 caudal centra. So we've got the back parts of 2 tail vertebrae and a caudal neural arch. So one of the, like, little upper parts of one of the tail vertebrae. Left humerus. Okay. So we've got an upper arm bone. Is that the first complete bone we have so far? Shoot. Acetabular region of the left ilium. That's the hip socket on the left side. Partial left ischium on the hip bones. Left femur. Okay. Thigh bone from the left side. Proximal and distal ends, so either end of the left tibia, shin bone. Proximal end of the left fibula, smaller shin bone. Left metatarsal 2, missing the distal end. Pedal phalanges 2-1, 2-2, and 3-3. And that's it. That's not a lot. So here is a helpful skeletal diagram showing you how much we have of this animal. The parts in gray are the parts that we don't have. Black is, flesh and muscle and everything. Gray is bone. The white parts are the parts of the bones that we actually have. So it's not a whole lot. It's really not a whole lot. Pretty fragmentary. I would be confident in saying this is a Tyrannosaur, probably. Just based on this material. What other big theropods do you have running around in North America in the late Cretaceous like this? So it's a safe bet, probably, that it's a Tyrannosaur. I'm sure the femur and fib are probably going to be pretty diagnostic there. Look at that part of the ilium. Skull bones are probably pretty diagnostic, too. At least down to, family level. But yeah, not a whole lot from this critter. Not a whole lot. But yeah. And Plane Shifter says, I wonder what Danny meant when he said they found a new species of Tyrannosaurus. That's not what I said. New species of Tyrannosaur. So a new species from the same family as Tyrannosaurus. So Tyrannosaurus itself is a genus. Tyrannosaurus rex. Rex is the species. This is a new species of Labocania, as the authors purport. Labocania is a species of probable tyrannosaur from Mexico. This was described back in the 70s. So this is, they're claiming they've got a new species of Labocania from the tyrannosaur family. And you were able to work with some holotypes and plants? Poaceae, and a very, very cool, Softy. That's really neat. They don't let just anybody handle the holotype specimens, the original. So that's pretty exciting. Very nice, Softy. Very cool. And Brody Plays Games says, what is your biggest find? The most important dinosaur I've ever found is, it'd be a ceratopsian dinosaur. Hopefully it's still going to be a new species if we can get that thing finally published. Yeah. Kind of similar to this guy. Chasmosaurus ervingensis. Yeah. That was back in 2012. Still not been published. We're working on it. Yeah. But yeah. And Ergo Urgle says, I love how you and fellow scientists explain the science for lay people. Awesome stuff. That's what I'm trying to do here, Ergo. I'm glad you appreciate that. That's my purpose for being here on Twitch. So, shoot, that makes me smile that you notice and appreciate that. So cheers. And Beist says, are there many baby or young dinosaur fossils? Yes, there are. And a lot of them weren't recognized as young dinosaurs either. People thought, oh, you know, must be new species because it looks like this other dinosaur, but it's smaller. That happens way more often than you might imagine, where a juvenile dinosaur gets mistaken for a new species. Yeah, and it makes things complicated. More than a little aggravating sometimes. For Chasmosaurus in particular, for this dinosaur, we've got some beautiful examples of babies. And thankfully, the people who found it recognized them as young Chasmosaurus. Here, I'll show you an example. Here we go.
Apparently, how significant ontogenetic changes are within a dinosaur species, we need to have fairly complete skeletal remains of both adults and the infants of the same species.
So what Phil Curry is talking about right here is what we call ontogeny. So ontogeny, ontogenetic stages, ontogenetic changes, is
ontogeny.
As dinosaurs grew and developed throughout their lives, from hatchling to adult, they changed a lot.
Ontogeny.
Lot. To the point where a lot of paleontologists got fooled and thought that they were different species. But no, it's just ontogeny.
Ontogeny.
So it's super important to understand. And so that's what Phil Curry is talking about here. You've got to have adults and juveniles, babies of the same kind of dinosaur, if you really want to understand how they grew, how much they changed, and all that good stuff.
In order to understand how significant ontogenetic changes are within a dinosaur species, we need to have fairly complete skeletal remains of both adults and the infants of the same species. As you can imagine, acquiring both skeletons of young and old specimens of the same species can be quite challenging.
Oh yeah.
Sometimes, though, we get lucky. Hiking through the Badlands of Alberta, I've made many exciting, wonderful discoveries over the years, but this one is one of my favorites. In the summer of 2010,
Holy cow.
I was going up cliffside, and I saw the edge of the frill coming out of
If the dinosaurs had not died, perhaps in some catastrophe, no reason to think dinosaurs wouldn't still be here, wouldn't still be dominating the Earth.
And we wouldn't be here. Yeah, Zacchiopath, thank you for the follow. Welcome to Paleontologizing.
For the years, but this one is one of my favorites. In the summer of 2010, I was going up cliffside, and I saw the edge of the frill coming out of the cliff. And when I looked at it, I thought, you know, that kind of looks like a ceratopsian skull, but I realized that my chances of finding a skull small were not very good.
No.
And I rationalized to myself this was probably a turtle rather than a skull at all. But I kept at it, and by the end of the day, had uncovered most of the skull, and there was no question this was one of the most exciting discoveries we've made in recent years. Baby dinosaurs are rare all the time, but baby ceratopsid dinosaurs are incredibly rare. We have never found one this small. And
that's... I think the baby Triceratops that Harley Garbani found. We were talking about Harley Garbani earlier. He discovered the original specimen of Labocania. The one that he found, that's smaller than this, I think. Let me grab it, actually. I've got a 3D print of it over here. There we go. Baby Triceratops. So this is comparatively even smaller, because an adult Triceratops will be so much bigger than an adult Chasmosaurus. So I think this is still like the youngest ceratopsid dinosaur that we found anywhere. Harley Garbani found this back in the 80s. But, yeah.
Specimen just kept getting better because as we worked on it, we realized that the vertebral column was there. We started to find ribs. We followed the vertebral column right back to the end of the tail, and we found the hind legs.
Nice.
Right here, the left one, the right leg is tucked underneath. What was a bit of a surprise, though, is we didn't find the front limbs. And eventually we realized, though, it's because
they'd eroded away.
Sediment here had been replaced by more recent sediments.
Yeah, so this part's just gone. Unfortunate. But anyway, we do find baby dinosaurs on occasion. They're rare and precious and valuable and important.
Take the phone to Mommy now.
Darth Jacoby. Thank you.
It's the dinosaur back.
Okay.
Absolutely love the content. I watch every day and will continue to as well.
Thank you, Darth Jacoby. I really appreciate that. Thank you for the ongoing support as well. Thanks for keeping me here online. That support. I do this full time, you know? This is how I make my living, believe it or not. Thank you for making that possible. Darth Jacoby, I appreciate it. Yeah, anyway. Baby dinosaurs are super, super important to study and to understand if we want to grasp anything about dinosaur ontogeny, how these animals grew and developed, because you don't understand dinosaurs if you don't understand how they grew and developed, you know? It's crucially important. I'd say much more important than it is for mammals, because they tended to grow larger from a smaller initial size. Dinosaurs hatch out of little eggs. Even the very largest dinosaurs that ever lived, the ones that are bigger than whales, ones that are 130 feet long, they still hatched out of eggs no bigger than this, you know? This is how big they were when they were born, and then they grow to be the largest animals to ever walk our planet. It's a lot of growth from this to that, you know? So, yeah, understanding that growth is crucially important for understanding these critters as animals, you know? Sauropod growth is insane. Absolutely, Puppy the Cat. Yes. And Gareth Jacoby says, also your emotes get compliments on every stream I use them on. That's wonderful. Emotes are a ton of fun, and I'm, yeah. The fun thing about dinosaur emotes is you can spam them just about anywhere, and people don't tend to get mad. They're like, wait, dinosaur emotes? What? So take that to heart, everybody. Use them wherever you can. Helps bring new people in. You know, and in our mission of trying to reach new folks and do good science outreach, bringing new people in is important.
Sure.
So yeah. But yeah. Little Pink Pony says, I tell everybody about this place. Thank you. This is lovely. No macro. Yeah, there you go, Salamander. I've got that on my my stream deck here, so I can just rapid fire these, you know? All that stuff. Anyhow. Somebody was asking me if I had a chance to photogrammetrize that sloth at La Brea. We'll take a brief detour and I'll talk about that before we get back to our Tyrannosaur paper. Tar pit stream. Here we go.
Oh boy. Try and wipe this off. Actually, take really, really detailed 3D models. Check this out.
Yeah.
Love these guys. This is so cool. So presumably these are from the 70s.
Oh, did you scorch Hellfire? Nice. Yeah.
This one in particular is very charismatic. It's going for a ground sloth hug here. Oh. I love this.
So my plan was to, after I ended the stream, take a zillion photos with my phone and then use an app to convert that into a 3D model. Maybe be able to print that. I am pleased to announce that we found success there. I'll show you. There we go. Yeah. We've got it. So I will be able to 3D print this guy here in our office. I am very excited about that. Yeah. Were those life-size? They were. Yeah. I will not be printing this one life-size. But it'll be really nice to have a 3D printed ground sloth here. Probably printed in bronze or copper color. And we can have him here whenever we're talking about Pleistocene critters. We can have him here in the background, you know? Yeah. So I'm excited about that. Anyway, we've got this critter up here too, which is... This is pertinent to today's discussion. All of this stuff is, you know? Talking about Tyrannosaurs today with this new Tyrannosaur just published. Yeah. Plane Shifter In says, I wonder why Tyrannosaurus Rex is so popular among all those within Tyrannosauridae. Well, T-Rex is the largest and the last Tyrannosaur. Also, I think the first one to be discovered. So, all of those things combined make Tyrannosaurus super popular. When you're the biggest and the last, when you're the pinnacle of Tyrannosaur evolution, it makes sense that you'd be the most popular, you know? So there's that. And Albertosaurus was discovered first? That would actually make sense, Deathsaurus. Yeah. Yeah, Albertosaurus was like 1890s, wasn't it? Tyrannosaurus was discovered 1900, I think. When was Albertosaurus named? Albertosaurus sarcophagus. Oh, nope, hang on, no, 1905. No. When was it discovered, though? Yeah, first discovery in 1884. Okay. So Albertosaurus was discovered before T-Rex, was named the same year as T-Rex, 1905. Yeah, okay. You're right there, Deathsaurus. By the skinnier Xiphonont teeth. And yeah, Dryptosaurus was way earlier, originally Laelaps. But we didn't even recognize that was a Tyrannosaur until very recently, so yeah. But yeah, fair. Fair, you're right. You're right. And Scarbius says, is there any, or has there been any evidence of any dinosaur being venomous? Yes and no. We've had, Sinornithosaurus venom. It's been suggested that this little feathery theropod, Sinornithosaurus, was venomous, based on the structure of its teeth, but that did not hold up to scrutiny. So we no longer think that it was venomous. So yeah, there's the long and short of it there, basically. Yeah. Yeah, there's an article about that if you'd like to read about it. There you go. And where did Ceratosaurus fit in? Great question. Am I evil? I'd wager you're not. Ceratosaurus was discovered before T-Rex. It was named by Othniel Charles Marsh back in the 1880s, I want to say. Ceratosaurus.
I'll just give you my message up front. Try not to go extinct. That's it.
And Deirdre, is that how I say that? Deirdre? Deirdre, thank you for the follow. Welcome, welcome. Ceratosaurus named 1884. Wow. Yeah. Nice. We did a whole stream about Ceratosaurus a long time ago. I can find that for you on the anniversary of its publication. But let me find that. I put together a quick little video of Ceratosaurus in film a couple years ago. Where did that go? There it is. Supercut of Ceratosaurus. Since it was discovered so early on, it got a lot of attention early on, and it was one of the... Early on, it was one of the very popular dinosaurs, you know? Appeared in a lot of different films, and... yeah. Ceratosaurus. Good stuff. Let me find that on stream, by the way. If you're really interested in Ceratosaurus, we did a whole episode on him a couple years back. Ceratosaurus, here we go.
You see, Griffith's experimentations with editing helped carve the inherent grammar of cinema. When we talk about
I even dressed up as Ceratosaurus.
Thank you for the follow. Appreciate it.
Trappy Jenkins. Thank you for that gift sub there. I appreciate it, Trappy. Appreciate that very much. Thank you. Yeah. So yeah. Anyway, I made that Ceratosaurus helmet. This was my Halloween costume a couple years back. Anyway, great to see you, Trappy. Thanks for that gift sub. Yeah. So the lacrimal crests are these little crests above the eyes. So the eyeball of this animal would be about the orbit
here,
right there. Yeah.
in the orbit. So what you see right here, this right here is the eye socket. So you'd have the eye right there. I could have put a big googly eye in there, but
anatomy lesson there.
A little bit too goofy, I think, for today's stream. Also, I didn't think about it until right now. So yeah. But anywho.
Deirdre. French pronunciation.
But the lacrimal crest
Deirdre?
here above
Appreciate you. Thank you.
That's what you see.
It's all related.
Right here. Yeah.
And it's got
That's the left one.
fossa goes all the way up into the crest. The crest is hollow.
Mm-hmm.
Yeah.
Dilophosaurus's crest is the result of taking this developmental pattern.
Anywho, good stuff. Here is a link to that VOD if you'd like to watch it. It's only got... Any views? Only 31 views. That's nuts. We got a lot more live. Yeah. Good stuff. Where were we? Oh, yeah. We're talking about our new Tyrannosaur here. Labocania Aguilone. Aguillone, I guess. That double L is kind of a Y sound in Spanish. Aguillone. So we don't have very much of it. I don't know if I would have given this critter a name based on such fragmentary material, but... So we've got a diagnosis right here talking about why it is a Tyrannosaur, and autapomorphies are unique characteristics. So these are special characters that are only supposed to occur in this animal. Those are marked with an asterisk right there. So strongly dorsally extended subocular process of the lacrimal along with the anteroventral margin of the orbit. I don't know if that's a super strong character, honestly. Broad anteromedial extension of the supratemporal fossa, extending far forward onto the frontal. I don't know. Those don't seem like the strongest characters, but I would expect this to be a new critter, given that it is from a new time and a new place, basically. It's just I wish the material were better, you know? And don't we always wish that? Arilo Rolo, I hope you're doing well. It's good to see you, too. Thanks for saying hello. And Crimson Carnotaurus, I am well familiar with when dinosaurs roamed America. Of course, I showed a clip from that yesterday when we were talking about Dryosaurus. Anywho. The small size of the animal and the presence of extensive striated bone and the lack of fusion between neural arches and vertebral centra suggest that this new specimen was immature at the time of death, although the relatively rugose bone of the maxilla, nasals, and lacrimal are consistent with a subadult or young adult. So they didn't do a histo on this, it sounds like. The broken femur shaft reveals a series of concentric rings in the cortex, which appear to represent lines of arrested growth. Lags are relatively widely spaced near the center of the bone, but more closely spaced toward the outside, suggesting decelerating growth. I'd like to see actual histo under the microscope here, but I guess we're not getting that. Anywho, let's get down to the phylogeny. The cladogram here has some of this fragmentary material. It's not the worst, but it's definitely not the best. And let's take a look at that phylogeny. So, this is, I've got some issues with this, to be certain. So like we were talking about earlier, this is a cladogram. So this is a proposed evolutionary family tree where you take a bunch of different characteristics, traits, features, characters as we call them, and you code them into a computer, and you have the computer spit out a family tree like this. It's an oversimplification, but it should work for our purposes here. Cladogram. There's a few really weird things going on with this cladogram that make me really suspicious. One of them is this. The most glaring thing, the thing that I can't ignore. I should really build up to it, but I just can't. I just gotta get it out there right now. You've got Tyrannosaurus Rex down here, and you have Nanotyrannus way up here. There's a general kind of consensus that these are the same exact animal. And so, the idea that you're getting basically a juvenile of T-Rex so far from T-Rex on the tree is a bit of an issue, you know? And Deathsaurus has basal traits in immature individuals? Yes. Ontogeny recapitulates phylogeny. Immature individuals will appear more basally on the tree, like they will have more basal characteristics, you know? So yeah. And there you go, little pink pony. Yeah, so Nick Longrich disagrees with me on this, of course. He's a proponent of the Nanotyrannus hypothesis that is a different kind of dinosaur. I'm not at all convinced that that's the case, but he just published a new paper about this back in January, I think it was. Yeah, here we go. Also in the Journal of Fossil Studies, interesting. A distinct taxon of small-bodied tyrannosaurs. So here's that paper right there. I'll give you a link. Thankfully, it's open access. But this kind of gets into a whole thing. A controversy, an ongoing controversy in dinosaur science. I'll show you a clip here. Because this really kind of... I've shown this many times before, but we've got new people here, and I feel like this is instructive. So we'll get into it. We won't watch the whole thing. I'll just skip around a little bit. An old TED Talk by my old boss, Jack Horner. And there you go, Deathsaurus. Yeah, Bistahyversor. Tricky taxon.
Tara asked for a show of hands or a clapping of people in different generations. I'm interested in how many are 3 to 12 years old.
And there you go, Charlie's Dragon, yeah. I know, right?
Nah.
Here, I'll be right back. I gotta go grab something.
All right, well.
Hang on a sec.
Talk about dinosaurs. Do you remember dinosaurs when you were that age? Okay. Dinosaurs are kind of funny. I mean, you know, we're going to kind of go in a different direction right now. I hope you all realize that, right? So I'll just give you my message up front. Try not to go extinct. That's it. People ask me a lot. In fact, one of the most asked questions I get is, why do children like dinosaurs so much? I mean, what's the fascination? And I usually just say, well, you know, dinosaurs were big, different, and gone. They're all gone. Well, that's not true, but we'll get to the goose.
Ontogeny.
So that's sort of the theme. Big, different, and gone. The title of my talk, Shape-Shifting Dinosaurs, the Cause for a Premature Extinction. Now, I assume that we remember dinosaurs, and, you know, there's lots of different shapes, lots of different kinds. A long time ago, back in the early 1900s, museums were out looking for dinosaurs. They went out and gathered them up. And this is an interesting story. Every museum wanted a little bigger or better one than anybody else had. So
there we go.
If the museum in Toronto went out and collected a tyrannosaur, a big one, then the museum in Ottawa wanted a bigger one and a better one. And that happened for all the museums. So everyone was out looking for all these bigger and better dinosaurs. And this was in the early 1900s. By about 1970, some scientists were sitting around and they thought, what in the world? Look at these dinosaurs. They're all big. Where are all the little ones?
Yeah. Legitimately.
They thought about it and they even wrote papers about it. Where are the little dinosaurs?
There was a collection bias. People wanted bigger dinosaurs.
Well, go to a museum, you'll see. See how many baby dinosaurs there are. People assumed, and this was actually a problem, people assumed that if they had little dinosaurs, if they had juvenile dinosaurs, they'd be easy to identify. You'd have a big dinosaur and a littler dinosaur. But all they had were big dinosaurs.
Yeah.
And it comes down to a couple of things. First off, scientists have egos, and scientists like to name dinosaurs.
It's true. This is an important point to make, and we don't often like to talk about this, because honestly, it's a little embarrassing. As scientists, we think of ourselves, we strive to be as objective as possible. You know, like Vulcans or something, I guess. I don't know a lot about Star Trek, but they're supposed to be logical, calculated, right? As scientists, we're not supposed to let our human emotions get in the way of the search for truth, for fact, you know? But we are very much human beings. We're flawed, just like anybody. Despite our training, despite our best efforts, we have biases. We like to name things. Everybody wants to name a new dinosaur, you know? So, yeah.
And it comes down to a couple of things. First off, scientists have egos, and scientists like to name dinosaurs. They like to name anything. Everybody likes to have their own animal that they named. And
it's a big honor to be able to name a critter like that, you know?
And so
there are people who go through their whole careers, they're like, I'm going to name as many taxa as I can, as many new organisms, you know? But that's an impulse that's often, I'll say, counterproductive to actual scientific discovery sometimes.
They found something that looked a little different, they named it something different.
Yeah.
And what happened, of course, is we ended up with a whole bunch of different dinosaurs. In 1975, a light went on in somebody's head. Dr. Peter Dodson at the University of
Charlie's Dragon, yes.
Pennsylvania actually realized that dinosaurs grew kind of like birds do, which is different than the way reptiles grow.
True. Yeah. Well, Cody Shibi's got a question. What do you think about people wanting to change the English names of all bird species named after people? I don't know. Those are common names. Who cares? You know, it's the scientific names that are important, you know? I don't know enough about birds to really have a strong opinion about that. So, sorry. I don't know enough to justify having strong feelings at all. I wish that were an attitude that more people would take, you know? Like, oh yeah, shoot, I don't know enough about that to have an opinion. What a refreshing thing to hear, right? Anyway, I don't really know anything about that. Yeah. Yeah.
And in fact, he used...
I admit that all the time. I like you, Cody Shibi.
And it's kind of cool. I mean, if you look at the cassowary, or any of the birds that have crests on their heads, they actually
guinea fowl are a good example
grow
too.
to about 80% adult size before the crest starts to grow. Now think about that. I mean, they're basically retaining their juvenile characteristics very
funny pumpkin
into what we call ontogeny. So allometric cranial ontogeny is relative skull growth. Okay, so you can see that if you actually found one that was 80% grown, and you didn't know that it was going to grow up to a cassowary, you would think they were two different animals.
Yep. And this is what's happened again and again with dinosaurs, is that you get all these different species that are named when, in many cases, it turns out they're probably just the same critter. When you actually cut open the bones and look at the interior structure there, you can figure out, like, oh, this one is still growing really rapidly. Maybe it shouldn't have its own name. Maybe it's just a juvenile of another species. That's what happened with Stygimoloch and Dracorex. Turns out they're both just Pachycephalosaurus, growth stages of the same animal, it seems. Yeah, likewise with, this is very controversial, but I think it's true, Torosaurus and Triceratops. And then less controversial is Anatotitan and
all right, so
Edmontosaurus.
So, you know, we can do this with a bunch of dinosaurs. You know, I mean, here's Edmontosaurus and Anatotitan. Anatotitan, giant duck. It's a giant duck-billed dinosaur. So
yep.
Here's another one. So we look at the bone histology. The bone histology tells us that Edmontosaurus is a juvenile or at least a subadult, and the other one is an adult, and we have an ontogeny.
Ontogenetic sequence, basically.
We get rid of Anatotitan.
Yeah.
So we can just keep doing this. And the last one is
here we go.
T-Rex. So there's these two dinosaurs, T-Rex and Nanotyrannus. Again, makes you wonder. But they had a good question. I mean, they were looking at it and they said, one's got 17 teeth and the biggest one's got 12 teeth. And that doesn't make any sense at all because we don't know of any dinosaurs that gain teeth as they get older, so.
And he means lose teeth. He misspoke there. But yeah, they actually lose tooth positions. We can demonstrate this.
It must be true. They must be different. So we cut into them. And sure enough, Nanotyrannus has juvenile bone, and the bigger one has more mature bone. Looks like it could still get bigger. And at the Museum of the Rockies where we work, I have 4 T-Rexes, so I can cut a whole bunch of them. But I didn't have to cut any of them, really, because I just lined up their jaws, and it turned out that the biggest one had 12 teeth, and the next smallest one had 13, and the next smallest had 14, and of course Nano has 17, and we just went out and looked in other people's collections, and we found one that has sort of 15 teeth. So
yep.
Again, real easy to say that Tyrannosaurus ontogeny included Nanotyrannus.
Yeah. Deathsaurus says, I wonder why they lose teeth. It's lose tooth positions, really. It's not just you're losing the tooth, but you're losing the entire tooth socket. So you just won't have a tooth growing there anymore. And it seems to be that as these animals are growing, their teeth are getting proportionally larger in their mouths. So if you want to have really, really big, thick teeth, you've got to make space for them. It seems like that's what they're optimizing for. That's what they're evolving toward, is just having larger, chunkier teeth in their jaws. The juveniles have got more teeth, and the teeth are smaller in proportion to their jaws. As their skull grows, as their jaws grow, the teeth are also growing proportionally larger in the jaw. Because it seems like that's, these big puncturing, crushing teeth. The bigger the teeth are, the more of an advantage the creature has. So it behooves them to have larger teeth in the jaws. Does that make sense? Yeah. Yeah.
And therefore, we could take out another dinosaur.
Yeah.
So, when it comes down to our end Cretaceous, we have 7 left. And that's a good number. I mean, that's a good number to go extinct, I think. Now, as you can imagine, this is not very popular with 4th graders.
Or with some other dinosaur paleontologists.
4th graders love their dinosaurs. They memorize them. And they're not happy with this. Thank you very much.
So, yeah, there you go. There's one more point. I think I skipped over it. But talking about similarities versus differences. Yeah.
You're going to determine whether you're related to your brother or your sister. You can't do it by looking at differences, right? You can only determine relatedness by looking for similarities. So people were looking at these and they were talking about how different they are. Pachycephalosaurus has a big, thick dome on its head, and it's got some little bumps on the backs of its head. And it's got a bunch of gnarly things on the front of its nose. And then Stygimoloch, another dinosaur, from the same age, lived at the same time, has spikes sticking out the back of its head. It's got a little tiny dome, and it's got a bunch of gnarly stuff on its nose.
Yep.
And then there's this thing called Dracorex, Hogwarts eye. Guess where that came from? Dragon. So, here's a dinosaur that has spikes sticking out of its head, no dome, and gnarly stuff on its nose.
Yep.
Nobody noticed the gnarly stuff sort of looked alike, but
almost identical,
they
really.
did look at these three and they said, these are three different dinosaurs, and Dracorex is probably the most primitive of them, and the other one is more primitive than the other. It's unclear to me how they actually sorted these three of them out. But ontogeny, if you line them up, if you just take those three skulls and just line them up, they line up like this. Dracorex.
Yeah, there you go. So anyway, that point about when you're only looking at the differences between them, like, of course you're going to think they're super different, you know? And if that's your starting point, if you're there to pick out small differences and kind of ignore the similarities, of course you're going to think that you've got a new species, even if you don't necessarily do. I think this is that combined with small sample sizes for so many of these taxa. In the late Cretaceous of North America, the whole Laramidian faunal endemism idea, I think that's what's going on for a lot of this. But that's just me, and I very well might be wrong about this. It's the awesome thing about science is that you're either right or you're wrong, and we'll figure it out, you know? Yeah. That being said, let's get back to our paper here. So yeah, this phylogeny here, this cladogram, having Nanotyrannus over here, its own little outgroup, separate from Tyrannosaurus Rex. I see no reason to think that these are not the same exact dinosaur, and yet to have this kind of disparity where Nanotyrannus is on the opposite side of the entire tree is a huge red flag for me. And yeah, do you see why that would be troubling? Yeah. And every dinosaur is a new species, Danny, says Peter Steves. Just admit it. We're all different enough to be our own species. This is all the Matrix. We've got a different meaning for the term matrix in paleontology. Peter Steves. Matrix refers to, like, the surrounding material that encloses a fossil. Matrix is the, you know, like in a lot of other fields, matrix is the stuff around. So it's the rock that contains a fossil. But yeah. Anyway. Matrix is chipped away. There you go. Dionysus triode. Yes, indeed. Yeah. So we use that term a lot. I was really confused when I first saw the movie, The Matrix. It was not what I was expecting it to be. Like, that's not what that word means. What? Anyway. And Axeman says, because a cladogram doesn't give you any insight into the human decisions that built it, correct? You need to decide if it is well constructed by the results. I mean, hopefully you'll be able to look at the data matrix. Again, using that term. That should be in the supplementary information. So it should be in the sup info for this paper. Pumpkin the Cat, thank you for gifting Crimson Carnotaurus. I appreciate that, Pumpkin. Thank you, thank you. Appreciate your generosity. And I'm sure Carnotaurus appreciates that. Good stuff. And you're paying forward the gift you got from Catatoon. Well, thank you to Catatoon as well. Thank you for paying that forward, Pumpkin the Cat. Appreciate you. Special thanks to the mods here who are awesome. They are indeed, Pumpkin. Yes, indeed. Yeah. Good stuff. Anywho. So this being said, I'm skeptical of this, but I might be wrong, you know? I could very well be wrong about this. I might be maybe Nanotyrannus really is a different kind of Tyrannosaur. Maybe it really is allied with the Aleoramines like this. I'm not necessarily convinced that those are valid. But anyway, yeah. There's a good chance that I'm completely wrong about this. And as a scientist, you have to be comfortable with that idea. Somebody's going to be right and somebody's going to be wrong. You follow the evidence where it leads, and sometimes your hunches are incorrect. Sometimes the data shows you wrong. That's fine, you know? At the end of the day, we are all striving for the same thing. We want to learn what's actually true. And if I turn out to be wrong about this, if Nanotyrannus really is an entirely different kind of Tyrannosaur that lived alongside T-Rex, you know what? Cool. That would be really awesome. To have two Tyrannosaurs in the same environment like that. In the Hell Creek, in this, like, Lancian fauna. That would be awesome. I would be happy to be wrong about that. I don't think I am, but maybe I will be. And that'll be cause for celebration, you know? So, yeah. Anywho. Yeah. A line from the Monk theme song. I haven't seen that. That's, he's a Catholic monk, right, Dr. Hubbs? What's the actor's name? Is it Tony Shalhoub? Yeah, wasn't that a spin-off from The Flying Nun? Remember that show? Let's see. Yeah. Remember this? That was anyway. The flying nun. No, I have it mirrored, but it's supposed to look like this anyway. Yeah. How many viewers did I lose during that little interlude? But yeah. And Patrick Crusader makes a very, very good point here. Yes. One thing that people often miss is that a dinosaur doesn't stay the same. They evolve. A T-Rex from 83 million years ago. Well, that's actually before T-Rex evolved, but point taken, Patrick Crusader. T-Rex probably first evolved around 68, 69 million years ago. But a T-Rex from earlier won't look exactly the same as one from 66 million years ago. Yes. This is why there are sometimes going to be findings that look conflicting because they're from different times. Makes it so much harder to discover if it's a new species or not. Absolutely, Patrick Crusader. Absolutely. Yes. Yeah. The thing is, when you're dealing with stratigraphic time like that, like I was talking about earlier, it's more complicated than modern biology. Because you've got an entirely new axis to worry about. You've got your y-axis, which is time. This is the way that Denver Fowler used to explain it to me. You've got all of this variation that might be due to geography, ontogeny, allometry, individual variation. And then you've got time as well. When you're looking at two different fossils, how much time is represented there? How much evolution has taken place between this fossil from down here and this fossil up here? That's another source of variation that makes things that much more complicated. And it's even more complex than that because ontogeny also varies stratigraphically. There's a thing that we call heterochrony. So like the way that creatures change during their lifetimes, all those ontogenetic changes, those ontogenetic changes also change through evolutionary time. So creatures might be undergoing pedomorphosis, where they're no longer like trying to reach that full adult stage. Maybe they look more like juveniles when you go up a few more million years in time. And maybe the adults just look more like juveniles then, that kind of thing. There's lots of sources of variation here. It's complicated, and this is why you need large sample sizes. And that's why it's not always best practice to name an entirely new genus or species based on fragmentary fossils. Because it's just, there's not enough information in there to really capture the nuance and the complexity that we have in these critters. Does that make sense? I hope so. Yeah. There you go, self-universe, yeah. Yeah. And Pumpkin the Cat says, I guess the good thing is you can always go back and review it and correct. Yes. To a certain extent, everything that we find in science will eventually be disproven or corrected or modified or have addendums stuck onto it. And that's cool. Like, honestly, that shouldn't be a distressing thing. That should be encouraging. Just the knowledge that, yeah, we're going to be wrong about a lot of stuff, but we're getting ever closer to what's true. It's always an eternally receding horizon. We're still advancing toward it. And we are learning so much as we go toward that. With each new fossil that we excavate, with each new publication, we're learning more and more about the history of life on Earth, and that, I think, enriches our everyday lives. It provides us a really important context for understanding the world around us and our place in it as human beings. I mean, think about that for a minute. Think about if you lived at a time when nobody knew that dinosaurs existed. You know, like George Washington lived and died without ever hearing about dinosaurs. Think about how sad that is, you know? Not having any understanding of the critters that lived here on our planet before us. What an impoverished existence. To not be aware of this marvelous history of life on our planet. To know that we are just here at the very end of it, so far. And there's 4 billion years of life on Earth that precedes us. It's like not being aware that there are other stars and planets out there. Think how much smaller your world would be. It's honestly a sad thought, you know? We are enormously enriched by our understanding of Earth's past, of all these critters that came before us. It gives us context that makes our world all the more richer and more vibrant. And I revel in that, you know? I almost think, in a sense, paleontologists, fossil scientists, we're almost public servants in that sense, you know? We're trying to make these discoveries about the history of life on Earth. We're making these discoveries for everybody. It enriches our lives as human beings, all around the world. everybody can appreciate a dinosaur skeleton in a museum. You know, ancient pollen grains that show what the plant life was like millions of years ago. Give us clues about the climate, about what these ancient landscapes looked like. It just provides this beautiful kind of framework that we can slot our own reality into today. Be like, things weren't always this way. The Earth has changed so much. You've had these massive upheavals in the history of life on Earth. You know, these great flourishings of different lineages of living things, and then these huge extinctions that occur. That knowledge, in a way, I think makes life more worth living. I think that's beautiful, you know? That's why I do what I do here. That's why I study fossils. That's why I'm so passionate about this. It makes life that much more beautiful to have this kind of understanding, to have that context. It's just so cool. It really adds a deep richness to our lives, I believe. I hope you think so too. Anyway. And there we go. Gamer's Tavern Show makes a good point here. You see it a lot in astronomy and astrophysics. There's a lot of concepts that are shockingly new. Like Star Trek mentioned a black hole back in 1968 when the concept was only solidified in 1958. We didn't find one until 1971. Didn't take a photo of one until 2016. I know, right? The concept of extinction. You know, that living things can go extinct. That species can vanish. The last individuals of a group of living things can just die out. That really wasn't well accepted until like 1830. It's nuts. Like, we had solid conceptions of the atom before we had like a scientific conception of extinction. That's nuts to think about, you know? Yeah. But yeah. Anyhow. And Winston's dog says, I believe Thomas Jefferson had a collection of many fossils. He did. He had some in the White House. Yeah. Including mastodons and ground sloths. Yep. Jefferson's ground sloth is named after our third president? Jefferson was the third president, right? Megalonyx jeffersoni. Jefferson studied fossils of it. He thought it was a giant lion, but, you know, it's named after him. Megalonyx jeffersoni. Yes, indeed. You could make an argument that Thomas Jefferson was the first American paleontologist because he was the first American to publish a scientific paper on fossils. And if that's your litmus test for who is a paleontologist, then, you know, he would count. Yeah. And there you go, Dr. Hubs. Yeah, good point. Thomas Jefferson didn't accept that animals went extinct and thought giant ground sloths were still roaming around. Yes. We might have a clip of that, actually. Not of Thomas Jefferson, but, let's see. I think it might be in here. I'm gonna spend just a minute trying to find this. Bob Bacher talks about it. How Thomas Jefferson gave Lewis and Clark instructions to look for some of these animals. Mastodons and giant ground sloths and stuff like that. And Winston's dog, thank you for the prime. I appreciate it.
Let's protect our fossils, because if they're removed...
Thank you, Winston's dog.
Forever.
Appreciate it. Holy cow. There we go.
Before science, it was often up to religious scholars to try and provide acceptable explanations for all of the giant, mysterious bones being discovered.
Yep.
One of the first was given by St. Augustine.
In North Africa, he saw a giant tooth, giant fossil tooth, probably a mastodon, big thing. A mastodon tooth looks a lot like a human molar, and he wondered how could there have been a human-like life form so gigantic and now extinct. He searched Genesis, and in chapter 6, he finds the description.
What's science ever done for us? TV off.
Ken Masters Dream. Thank you for the follow. Welcome to Paleontologizing.
Of these mystery people, hybrids between angels and people. They were evil giants, and they were wiped out. And he said, could this be?
Hundreds of years later, the question still remained unanswered.
This is what people tried to make sense of fossils back then.
An English reverend and museum curator named Robert Plott correctly identified a dinosaur fossil as a petrified bone. But he described it as the thigh bone of a human giant.
Oh boy.
It wasn't until the 1800s that people were beginning to accept the possibility that the fossils belonged to some strange, non-human animals.
As fossils began to be studied in great numbers, serious philosophers, Thomas Jefferson being one, looked at these fossils and said, what is the message there? Could nature allow wonderful animals to go totally extinct worldwide? And he told Lewis and Clark, when they went to the American West, be on the lookout for mastodon bones, for live mastodons, for mammoth turds, any evidence that these animals might still be alive somewhere.
Yep.
Of course, in their travels across the continent, Lewis and Clark found no such creatures.
They did find some dinosaur fossils, though.
That certain plant and animal species had simply vanished from the Earth. The evidence seemed overwhelming, and by the 20th century, dinosaurs became synonymous with extinction. While some held out hope that a few survivors might still be found in an unexplored jungle, or in the depths of Loch Ness, such notions were most often dismissed as sheer fantasy.
Yep.
Then, towards the end of the 20th century, when just about everybody on Earth was convinced that all dinosaurs were extinct, scientists changed their minds.
Yeah, we realized birds are living dinosaurs.
You don't need to go any further than just out into Central Park and look at the pigeons. Birds really are living dinosaurs.
It's true.
Today.
Anyway, that's the general consensus now. You'd be hard-pressed to find any paleontologists, zoologists, evolutionary biologists, ornithologists, bird scientists who would dispute that. That's the general consensus. All of the evidence points to birds evolving from dinosaurs, and thus birds are living dinosaurs. Pretty cool to think about. But yeah. Anyway. Yeah. Kuasil says, humans are always so self-obsessed. Like, there are a million species around the world. You find a bone and bang, it's gotta be human. I know, right? What? Yeah. What can I say? People like to think about people. You know, we're pretty people-obsessed as people, aren't we? Yeah. It's kind of funny, like, when you think about the YouTube videos that are put together for, like, dogs and cats, they're, like, of other animals and stuff. Think about the YouTube videos that are put together for people. Like, it's usually people on the screen talking or whatever. If you were watching a person right now, granted, we're talking about fossil organisms, but still, you know, we're interested in people. It's just how we evolved to be, you know? Yeah. But I get your point there, Kuasil, absolutely. Yeah. And were there birds 70 million years ago, self-universe? There were. A bunch of different birds. Birds first evolved about 160 million years ago, or maybe a little bit earlier than that. But yeah, we've got lots and lots of birds from the Mesozoic, from the age of dinosaurs. Many of them were kind of weird. Some of them had claws on their wings, teeth in their mouths. holdovers from their dinosaur ancestry. And most of them went extinct when that asteroid hit 66 million years ago. It's something like 94% of bird species died out when that asteroid hit. About 90% of mammal species, too. It's only a few species of birds that survived, and they, in the aftermath, took over the world. They diversified into a huge number of species, you know? Most estimates put it around 10,000 species of bird around today. And they all diversified from that slim minority that survived the extinction event. So yeah. Yeah. And Jesse Vanita says, I always find it funny to think I had a pet dinosaur when I had a pet bird, but you 1,000,000% did. Yeah. All birds are living dinosaurs. They evolved from dinosaur ancestors, thus they are dinosaurs. That's how it works. So yeah. And imagine if that number was 100%. No birds in the park? Yeah, self-universe. I mean, we don't have pterosaurs anymore. 100% of them went extinct. Our incredible flying reptiles from the age of dinosaurs. They were completely wiped out. Not a single species survived, as far as we know. Yeah. They had existed on our planet for hundreds of millions of years. From the, like the middle Triassic until the end of the Cretaceous. It's like 170 million years, give or take. Huge diversity of forms and species. Yeah, all gone at the end of the Cretaceous. Wild to think about. But yeah, they disappeared entirely. And the birds almost did too. But a few species managed to survive. Makes me so sad, says Petrodactylus. I know, me too. Pterosaurs are such cool animals. They really are. And turtles mostly survived, right? So Scoobs, yeah, turtles actually did really well. So it's only like less than a quarter of turtle species died out. 22%. And it's only the big land-living turtles that died. All the ones that lived in ponds and rivers and stuff, they seem to survive. There's a big size bias here. Like, the biggest animals are the ones that die out at the end of the Cretaceous. But that being said, even some of the smaller guys, birds, lizards and snakes, mammals, they almost get wiped out entirely too. Living in a freshwater environment seems to have been your ticket to, hopefully, survival at the end of the Cretaceous when that asteroid hits. The turtles, the crocs, the champsosaurs, some of the fishes, the salamanders, they did okay. Living in rivers and lakes and swamps. Many of them dig burrows. They can just feed on basically garbage that falls into the lake, you know? They're detritivores, many of them. They did pretty well during this time. Fairly resilient there. Many of those critters don't do well with pollution nowadays, but pollution wasn't the issue back then. The issue was the sun being blocked out and plants dying and that food chain basically collapsing. But there in the rivers and lakes and swamps and streams, creeks, bogs, they could make a living, you know? Just waiting things out and eating crud that would fall into the water, basically. Yeah. But yeah. Anywho. And Kua Seal, that's a great question. That idea that the Cambrian explosion is kind of overstated. That it wasn't really a massive explosion in diversity, but more of a creature starting to evolve hard parts, which are more readily fossilized. It's an interesting idea. Makes a lot of sense. I don't know enough about that to have a strong opinion, honestly. And N Simplex Pachinko, how are you doing? Listen to that hot new sound. Thank you for the raid.
Has a new sound for their 3
How are you
listeners.
doing? Welcome to Paleontologizing. Thanks for joining us. How are things? How was your stream? I hope it was real good. Welcome to Paleontologizing. Doing logistics. Well. Very nice. I hope it went well. Oh, I need to check on my 3D printer too. We've not looked at that this whole stream. I just started a brand new print at the beginning of our stream today. We failed to look at it until right now. But this is, let me change our lighting a little bit there. Let's try... These are all too dark. That's better. I like that. We'll switch. Well, that'll be fine. Whatever. We'll use that. Yeah. Printing part of a Majungasaurus skull. I've got maybe 1 or 2 days worth left of printing for this. Printing it piece by piece. We were talking about this yesterday, so apologies for the repetition. Again, apologies for the repetition. But printing a life-size Majungasaurus skull here. I'm very excited about. Majungasaurus is a wonderful carnivorous dinosaur from the late Cretaceous of Madagascar. And it's got a crazy-looking skull. And we are printing it. Excited about that. Don't neglect the printer. I didn't hear any bad noises coming from it, so I assumed everything was good. And it is. Yeah. Good stuff. So I'm printing, let's see, this part is, I think, the temporal fenestra in the upper left of the animal's skull. Yeah. And,
let's protect our fossils, because
persuasion.
if they're removed, America loses them forever.
Thank you for the prime. I appreciate that persuasion. Thank you, thank you. Thank you for that. Keeping me here on the air with that financial support, it means a lot. This is how I make my living, and so that contribution helps. Thank you for that. Thanks for the interesting content. You bet. It's good to have you here. Let me know if you've got any questions. And Crimson Carnotaurus says, some people like to mount taxidermied deer and bears above their fireplace. Imagine how cool a 3D printed theropod skull would look as a similar decoration. Oh yeah. Well, we've got that right here. We've got our juvenile Tyrannosaurus skull here. Don DeBlue, assistant state paleontologist for the U.S. state of Utah. He's got a Diabloceratops above his fireplace. Let me find that for you. Come on, Google Photos. There we go. He discovered Diabloceratops, so he very much deserves to have that. But, there it is right there. He discovered this dinosaur. And so, yeah. So Don's wife, Amy, got this for him as an anniversary present. It's an exact copy, a replica, molded and cast from the original. That's pretty awesome. He's got a bunch of Diabloceratops decor. That's kind of the standard gift to get for Don. Yeah, so he's got a bunch of different examples of Diabloceratops stuff. Here's just a small smattering. There's a framed art print The original artist gave him this. This might be the original or it might be a print. I forget, but yeah. There's a sugar skull Diabloceratops there. A few pieces are broken off. I think he's since glued them back on. There we go. A leatherwork tray and a plastic Diabloceratops from Safari Limited. Yeah. So yeah. Cool stuff. It's really neat when you found a new kind of dinosaur, you know?
Certainly there are many more dinosaurs waiting to be discovered.
There are many more still out there.
Mysteries waiting to be pondered.
Dark Lord Platypus, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. So yeah. Sin Calzones, I love your name. It's good to have you here. And thanks for being here, Dark Lord Platypus. Welcome. And especially a dinosaur that looks cool. Yeah, Diabloceratops is very charismatic. It's just a really neat looking critter. It's just very cool. Gotta love Diabloceratops. I've met some people for whom this is their favorite dinosaur. I like this one. Looks very infernal. The Devil's Horned Face, Diabloceratops. And what is this? Ale Dream Gameon, thank you for the follow and welcome to Paleontologizing. It's good to have you here. Yeah. How are the feline research assistants? They've been good. Sweetie Pie was very insistent about being on stream today. I'm not sure where she went. She's probably eating dinner. Yeah. Yeah. Imagine trying to accommodate something as big as a Pentaceratops skull in your house. You have to be a big house. Yeah, Pentaceratops has got one of the largest skulls of any dinosaur. It is enormous. Gigantic. It's got a ridiculously big ol' head, Pentaceratops. Just... it's nuts. Almost too big, you know? That gives you some sense for how big it would be, yeah. Yeah. Anyhow, cool critter, Pentaceratops. Here, one more picture. Facebook. There we go. Look at that. It's just a ridiculously gigantic skull. It's so much bigger than the body of the animal, you know? Just nuts. Ridiculous. Ridiculous. Look at that, you know? Crazy. Yeah. Anyhow. Yeah. Back problem, says Quake. Well, these animals had extremely robust necks and huge occipital condyles. So the occipital condyle is like the ball and socket joint. It's on the back of the skull that hooks up to the atlas vertebra. It's like a ball and socket kind of a deal. They're enormous on these guys. On Triceratops, they got pretty big too. I can show you a photo. There we go. It's here on my Instagrams. There we go. There is the occipital condyle of a Triceratops. This is one I helped dig up back in 2014 at the Burke Museum in Seattle. But, yeah, here. Here it is on a baby Triceratops. There's the little occipital condyle right there. See it? A little round ball there, trailer ball. There it is on an adult Triceratops, or at least a subadult. It's big. If you've ever hooked up trailers to trucks before, you know, like the standard 3.5-inch trailer hitch ball? This is so much bigger than that. It's nuts. So, yeah. Pretty cool. That's not a cannonball. No, Mayor Space. A Triceratops occipital condyle. No. Very cool. But yeah. They were hauling a trailer. Yeah, their head is basically a trailer. Really putting the cart before the horse there, huh? Yeah. Pretty neat. And I think we might even have a clip of that flexibility thing. Let's see. Where was that? Looking. Here in this video. There we go.
Disney's robotic Styracosaurus, a relative of Triceratops, has also gained from the new paleontology. It was once perceived as a lumbering animal, with a huge head stiffly mounted on its body.
Not stiffly. Oh boy.
And front legs splayed to the side, like a lizard's. Recent studies show that its head was connected with a limber ball and socket joint.
Yep. Not recent. We've always really known this. It's just nobody really paid attention to
neck
that.
Muscles could toss the head in any direction. Though we're getting closer to knowing how dinosaurs lived, moved, and acted, we're still a long way from knowing everything about them. But we're on the right track.
Oh, yeah.
19th century scientists greatly expanded dinosaur science.
They established dinosaur science.
Men like Jack Horner and
There's
Robert
Jack, my old
Butler
boss.
have done the same.
Yeah.
Inevitably, the discoveries and theories of today will be disputed in the future.
Yep. Always.
But one of the new ideas is not likely to change. That far from being giant reptiles, dinosaurs were among the most complex, diverse, and successful creatures that ever existed.
They're still reptiles, though. Just like birds are. Anyway. Yeah. They were huge after... There you go, Gravity. Absolutely. Yes. Good stuff. Anyhow. And were dinosaurs so big due to the high levels of methane? No. So, there wasn't a huge amount of methane in the atmosphere during the age of dinosaurs. There also wasn't a huge amount of oxygen either. I don't know where this myth comes from, but a lot of folks in the general public seem to have this idea that, like, dinosaurs were able to get as big as they did because of the atmospheric composition back then. This idea that there was that much more oxygen in the atmosphere, and so dinosaurs could get super, super large as a result, and that's bunk. It's not true. Dinosaurs were around for a long time, from late Triassic to the end of the Cretaceous. It's like 178 million years, give or take. And during that time, the composition of Earth's atmosphere did fluctuate. There were big changes that occurred. But the oxygen levels, you know, I'm not going to say they were constant, but they didn't swing wildly or anything like that. It's not like oxygen levels were much higher back then than they are today. In fact, during certain parts of the age of dinosaurs, oxygen levels are probably lower than they are today, you know? And so it's certainly not because of high oxygen that dinosaurs are able to get big. Dinosaurs were supremely well-adapted animals to their environment, and some of them achieved truly gigantic sizes because of their cool evolutionary adaptations. The big sauropod dinosaurs, for instance. Many of them were able to get so very large based on a number of factors, including pneumatized skeletons. We talked about this a little bit yesterday, but I'm going to repeat it again. Love this figure here. From my friend Carrie Woodruff's paper on lung disease, respiratory illness in a sauropod dinosaur. So this is a young sauropod dinosaur here, a diplodocid, like Diplodocus. Everything you see in blue is air. These animals were all full of air. They had these huge air sacs in their torso right here, and this like nice electric blue. That darker unsaturated blue is their lungs. And then the light blue, this powder baby blue here, sky blue, are pneumatic diverticula, basically like air sacs and air hollows in their vertebrae. These were extremely efficient animals. Supremely well adapted to life on land. It's one of the reasons they're able to get so very, very large is because not only does this offer lighter weight, more easy to move their bulk around on land, but also it helps them oxygenate their cells too. It's much easier for them to get oxygen, life-giving oxygen to all their cells in their body because their respiratory system is basically stretched like that throughout their whole body. Super cool, right? Yeah. Anyway. Yeah. So yeah. Yeah. I wonder if we can find a video about bird respiration and bird air sacs. And we might look at that tomorrow. By the way, I forgot to talk about it yesterday. But we're going to try and do Thursday Birds Day tomorrow. That's a fun thing that we used to do on this channel until, like, May. I left for the field to go dig up dinosaurs during the summer, and we've been so busy since then that I just haven't gotten back around to doing Thursday Birds Day. But, let's do Thursday Birds Day tomorrow, shall we? Here we go. Avian respiration. Here, take a look at this. Actually, no, this is not the one that I was looking for. Hang on. Well, I don't know. Maybe we might just do this tomorrow. But yeah. Anywho, if any of you are not familiar with Thursday Birds Day, in fact, many of you probably are not, let's play the little video stinger for Thursday Birds Day here real quick and kind of introduce you to that. We'll do this tomorrow, so get your bird pictures in now. Thursday Birds Day.
Hold on, something's coming out of here. Look, there's a bird, dude. It knows what's good. I'm telling you, I just heard it inside.
I don't care if Monday's blue, Tuesday's gray and Wednesday too. Thursday, I don't care about you. It's Thursday.
Thursday Birds Day.
Birds are all around us in everyday life. But most of the time we hardly even notice them. Thursday Birds Day is a step toward correcting this oversight. Do you want to be part of Thursday Birds Day?
I don't know.
Here's how you can contribute. Go outside during the week and pay special attention to the birds around you. See if you can take a picture of a bird. It doesn't have to be a good picture. Any old photo will do. Upload the picture to the Discord and we will discuss it on Thursday. Simple as that. Thursday Birds Day is an invitation to go outside and appreciate the grandeur of the natural world. It's a reminder that Since birds are theropods, dinosaurs still enrich our daily lives.
It's great!
And finally, it's a celebration of the amazing history of life on our planet. So, happy Thursday Birds Day!
There we go. Thursday Birds Day returns tomorrow. I can't wait. Yeah. So, yeah. If you've got a bird photo, especially one from this week, upload it to the Discord there in the Thursday Birds Day channel. Claire Birth, thank you for, yeah, making a new one there. Excellent. We'll take a look at those. Celebrate the dinosaurian origin of birds. The fact that dinosaurs never went completely extinct. We still have them today. Over 9,000 species of them. All the birds. So yeah. You have about 20 hours to get your posts in for tomorrow, everyone, says Claire. I'm hoping we won't have as many posts. Be quicker to go through. But yeah. I never showed the PBS Eons video on the California condor for Thursday Birds Day before. I don't know if I have, Dr. Hubs. I don't know if I've seen PBS Eons video on the condor. But we saw some live condors just the other day at the Oakland Zoo, which is a ton of fun. Yeah. Let's see if I can find that clip. Oakland Zoo 2. Back to our condor. There we go.
California condor. Look at that wingspan. That is truly impressive. Yeah. And again, this is the living condor. This is not even as big as the giant condors from La Brea like we saw the other day on our stream.
Yeah.
Those teratorns. This is just your extant living California condor. It's this big. What an incredible animal.
And then here's some live ones.
With me, unless I'm
There's a condor up there. Yeah.
You can see so many cool things up close if you just bring binoculars. I don't know why everybody doesn't bring binoculars, you know? It seems like such a simple thing. To be able to get so much.
Not everybody has binoculars, Danny. What are you talking about? This guy, you know?
Yeah. Anybody in chat ever bring binoculars to the zoo?
I do every time.
Essential item.
Unless I'm streaming. Yeah. Anywho. Love condors. Yeah. And they can get heavy. Well, you know, they're big birds, Claire Burr. So, but they're light enough to fly and soar as they do. Yeah. Anyway. And Dr. Hebb says, I used to walk around the mounted Teratornis skeleton when I did research there at least once a week. Yeah. And Lordy, how are you doing? Hello, Lordy. Must be late where you are. Lordy is on East Coast time right now. But yeah, Lordy, I hope you're doing well. It's good to see you. And DCI Bank says, if birds are dinosaurs, then how come bats don't come from eggs? Well, they do. Bats do come from eggs in the same way that you and I do. Not hard-shelled eggs, but eggs internally. You know, sperm and eggs, make mammals, you know. Yeah, but bats are mammals, yes, very much. But yeah, can I find you a picture of a bat egg? There we go. They look like this. Or like this. Oh boy. Under microscope. No, I don't know. Anyway, all mammals they don't lay eggs. Only a few mammal species lay eggs, but mammals do have eggs internal to them. You have the sperm and the egg, you know how it works. The birds and the other birds. Yeah. Anyway. Yeah. Anyway. Where were we? We haven't gotten through this paper yet. Let's finish this out, shall we? Our new Tyrannosaur paper. Right here. The critter probably is new. I just wish we had better material from it, and I wouldn't be... I don't know. I don't necessarily agree about the whole fondle endemism thing, but, you know, that's me. And I very well could be wrong. This critter does come out, this new Tyrannosaur, comes out fairly close to Dynamo Terror on our cladogram here. Dynamo Terror from New Mexico, and we just saw this critter down in Hemet, California. We saw the holotype of this animal. That was right... Where did that go? There we go.
Was attached to something. Everything was basically all this articulate.
I hope we can find these videos on YouTube here today. So it looks a lot like T-Rex, but it might have proportionally larger arms and a smaller head.
Dynamo Terror.
We do.
Very cool.
All ages.
Yeah.
Yeah.
Very cool. And it's
There we go.
Is this Dynamo Terror? Yes, indeed.
There's the original fossils there. Super cool.
This is one of those dinosaurs that's got a, we'll say a highly evocative name.
Dynamo Terror.
But you know,
Oh,
all
boy.
dinosaur names are made up. We name them. They don't come with naming labels. We have to come up with those names. And Dynamo Terror kind of delivers what it promises. It's a Tyrannosaur.
Yep.
Those.
And the Museum in Hemet. Absolutely. The Western Science Center, Dr. Morbius.
Those
I'll
are
give you a
cast-
link
no,
to
these
the
are 3D
VOD.
prints of the original bones. You can see the print lines, I think, right? Do you see those striations running across?
Yeah.
They're subtle, but they're
But
there.
it looks really good. It's well painted.
Yeah. Pretty sure those are 3D prints.
They are. I can tell.
Yeah.
Thank you, Claire.
So this is a relative of T-Rex, but older and smaller. In 2018, our team named a new species of Tyrannosaur based on an incomplete skeleton from the Menifee Formation in New Mexico.
Yep.
Dynamo Terror Dynastes, a mix of Greek and Latin words meaning powerful terror ruler. It is a fitting name for a Tyrannosaur. Although missing many
Yes,
bones,
indeed.
it showed that there was a previously unknown Tyrannosaur living in New Mexico 79 million years ago.
Pretty cool. And that, according to the cladogram here, is pretty close to our new Tyrannosaur from Mexico, Labocania Guiana. So it's neat that we can connect this to a dinosaur that we just saw in person on our live stream from last week. Pretty neat. And people are talking about what kind of critters bats are. Are bats birds? Are they... They're not birds. But that reminds me of one of my very favorite Calvin and Hobbes moments. Yeah. And this was a whole storyline, wasn't it? Yeah. Well. He says, what are we going to do about this report on bats? You've got to help me, Hobbes. You've got to write a book report. First, let's make a list of what we know. He says, yeah, that's a good way to start. Number 1, what are bats? Kevin says, they're bugs, aren't they? Yeah, put that down. Number 1, bats equals bugs. I was just like, are you sure? They fly, right? They're ugly and hairy, right? Come on, this is taking all day. Anyway, he gives this report to the class, and, yeah. Says, my report is on bats. Ahem. Dusk, with creepy, tingling sensation, you hear the fluttering of leathery wings. Bats with glowing red eyes and glistening fangs. These unspeakable giant bugs drop into... And the whole class shouts in unison, "Bats aren't bugs!" Anywho, there's a lot more there, but I always thought this was a particularly funny storyline. It deals with taxonomy and just, I don't know. Having such a lout here, I find that really funny. Almost in a Homer Simpson kind of way, where he's just so clueless that he's clueless about how clueless he is. But he's very confident nonetheless. I think that's funny. Oh, yeah. Bats are mammals, exactly, Gravity. So bats are actually related to, I kind of forget. Are they related to ungulates? Let's look at our tree of life here. Bats, the clade is called Chiroptera. There we go. Which means, what is it? Arm wing or finger wing? Hand wing is what it means. Chiroptera. Bats, right here. 1,055 species. It's like 1/4 to 1/5 of all mammal species are bats. They're extremely speciose, very diverse, and they are related to carnivorans and perissodactyls. The odd-toed ungulates. Cool. They used to be thought to be related to primates, and I think that idea has since fallen out of favor with more DNA evidence. Turns out they're not super close to primates. 20% apparently, which is insane. I know, right? Bats are incredibly speciose, super diverse. And there you go, DCI Banks. Yeah. Good stuff. Yeah, and some bats are called flying foxes. Yeah, the diurnal bats, what we call megabats. I think another group for them is flying foxes. Yeah, I've got multiple species of flying fox here. I'm not sure if flying fox is actually a clade name, but all the flying foxes are megabats. And we saw these at the Oakland Zoo when we were there. And Patrick Crusader says we call them flying dogs here. But that's the cool thing. No matter what country you're from, no matter what language you speak, no matter what your regional term for these animals will be, this term here, Theropodidae, will be the same. This is the reason why we have scientific names, as they transcend national boundaries, they transcend languages. The scientific name is an international thing that all scientists use to communicate with one another. I think that's really neat, you know? We've talked about that many times on this channel, so I'm not going to get into it right now, but it's cool to think about, you know? Yeah. And we love those here. Zorros voladores. Yeah, flying foxes, Gravity. En español. Claro que sí. Yeah. Anywho. Yeah. But yeah. Good stuff. Let's finish out this paper on Labocania aguilonae. So it's got similarities to Bistahyversor, which is another theropod dinosaur, another tyrannosaur. Bistahyversor, but I hardly know her. Right there. And this name, it means, I think, the runner from Bista, which is a place name. I remember when this critter was first described. I was just starting off my studies at Montana State University. And this critter was newly announced. I think it was published in the Journal of Vertebrate Paleontology. But, yeah. So this seems to be a close relative of our new Tyrannosaur. Comes out pretty close to it. Bistahyversor and Labocania aguilonae. They're claiming some subtle differences in the skull here. Yeah. So the new critter Labocania. The relationships of Labocania, that older genus, have long been unclear, and its age is poorly constrained. In the original description, Molnar remained ambivalent about the animal's affinities, comparing it to Tyrannosaurs, Carcharodontosaurs, and Abelisaurids, and emphasizing supposedly unusual features in Labocania, including the thickened frontals, absence of well-demarcated supratemporal fossa, and the shelf of the dennerae. Since then, Labocania has been ignored in the studies of Tyrannosaurus, and its affinities have been considered or uncertain. A recent study classified Labocania as a Carcharodontosaur. As part of this study, we re-examined the holotype of Labocania and can confirm that in all aspects of the morphology, its anatomy is consistent within Tyrannosauridae. So they almost buried the lead here. That might be the most important part of this entire paper, is kind of re-evaluating this old genus, Labocania, described in the 1970s, and saying, hey, this critter is a tyrannosaur. And this new Tyrannosaur specimen that we have, we're going to say it's within genus Labocania. It's within that genus. That's important in and of itself. And I could be happy about this paper because of that, for sure. That's really neat. Yeah. Yeah. Confirmed in section 4.4. There you go, Gay Hibiscus, yeah. Yeah. And what did it to eels? Oh, so that name, Anguillinae, is not like Spanish anguilla. It's a person's name. Etymology. The species name honors Martha C. Aguillon, discoverer of the specimen and a long-time career paleontologist of Coahuila, Mexico. So it's named after a cool lady who worked on fossils in Mexico. Anywho. And Gay Hibiscus says, I don't know why the reviewers didn't send it back saying, please edit this to be earlier. I think maybe because second author on this paper is also chief editor of the journal. I think that's why. Also, it's not really something you'd send back to... I don't know. It's not a big deal. But yeah, Nick Longrich, who's second author on this, I think he helps run the journal. I think he's, he might be chief editor, I'm not sure. Anywho, very nice. So here we've got kind of a faunal assemblage. These different dinosaurs that are all roughly from the same time and place. I've long suspected that Velafrons and Laterinus might be the same animal, but anyhow. Just like you've got up north and in other dinosaur faunas, here in the late Cretaceous, the Campanian, you've got tyrannosaurs, you've got ceratopsians, you've got hadrosaurs, duckbills, all doing their thing. Pretty much no matter what environment you look at, in the late Cretaceous of Laramidia, you see a similar assemblage. You got your tyrant dinosaurs, you got your horned dinosaurs, you got your duck-billed dinosaurs. If you're really lucky, you might get your armored dinosaurs, your ankylosaurs, and your bonehead dinosaurs, your pachycephalosaurs. Maybe some dromaeosaurs, oviraptorosaurs, troodontids, etc. Maybe some leptoceratopsids if you get real lucky. But it's cool that, like, kind of no matter where you go, you've got a similar cast of dinosaur characters. You know? Here. Horseshoe Canyon Formation fauna. There you go, from the Horseshoe Canyon Formation, ankylosaurs, ceratopsians, ornithomimosaurs, tyrannosaurs, etc. A lot of these are probably oversplit. But yeah. Pretty neat. That you just get this kind of consistency through different dinosaur-bearing formations. Let's look at, Dinosaur Park Formation. You got your duckbills. You got your armored dinosaurs. You got your tyrannosaurs. You got your little theropods. You got your ankylosaurs. And these cast of dinosaur characters, they change from time to time, and geographically too. I think a lot of that is probably more temporal than it is geographic, but that's my bias. It's neat. And the idea that we're starting to figure this out finally, you know? That we're finally starting to figure out which dinosaurs lived at which particular times. These are grossly oversplit, I think. But we're dealing with like 3 million years there, to be fair. But yeah. It's really neat just to see this. The puzzle pieces, like, fitting into place there. The more we study these different dinosaur-bearing formations, the more we start to understand which dinosaurs lived at which times, and you see these patterns emerging. Where, like, you start working in a new formation, like we were doing this summer in the Almond Formation of Wyoming. There's no dinosaurs named from that formation. But we know that we've got horned dinosaurs, we know that we've got duckbills. There's going to be tyrannosaurs in there. There's going to be ankylosaurs. There's going to be pachycephalosaurs. Probably ornithomimids. We know what to expect. But digging those dinosaurs up, being able to say, hey, these are really cool. It's really neat how they differ from previously known dinosaurs, potentially. That's the exciting stuff. And eventually, one day we'll get to a point where we've got enough dinosaur formations with complete enough dinosaur rosters that we'll be able to just say, hey, these guys evolved into these guys, who evolved into these guys, and we can track those trends, look at how they're changing. We're starting to get to that point in a few areas, but there's still a lot of incomplete information. But we're getting there, you know? And I find that intensely exciting as a dinosaur paleontologist. That we're finally gathering enough information that we can make predictions, and we can see those predictions come true through detailed study of these fossils. That's super exciting to me, you know? Oh yeah. What technology are we missing, says Scoobs. It's not really a technological problem, it's just having the funding, and the time, and the personnel to go out there. The way that we dig up dinosaurs hasn't changed that much since, like, the Wild West days, since the 1880s. It's not a technological problem, it's a people power problem, a funding problem. We need to get out there and we need to dig, we need to collect specimens. Yeah, does that make sense? Yeah. We need to build a money-making machine. There you go, Deathsaurus, yeah. Yeah, the old counterfeiting machine. Need to get me one of those automated teller machine automatrons. Ones that just spit out the money. That'll solve all our problems. Yeah. Yeah. And tricoders and transporters would help, though. There you go. Maybe some shuttles. Replicators. There you go. Yeah. Anyway, on that note, I've got a lot of stuff I got to take care of tonight. And so we are going to wrap up today's stream. But welcome to the world, Labocania Aguione. And thanks for walking through this with me today, everybody. Hope you enjoyed it. Hope you learned something. And our 39th new dinosaur published this year. Very exciting. Anyhow, let's go ahead and wrap up today's broadcast. Don't go away. We're going to go right into somebody else. Maybe somebody else doing some science. Thank you to everybody whose names will be appearing presently in our credits. Let's see. Let's go say hello to Science Streams, shall we? And Bonaire Condonaire, thank you for the follow. Welcome to Paleontologizing. We're gonna go see what fellow scientist Blint is up to. Doing some science here on Twitch. Thank you so much, everybody, for your viewership, your attention, your questions, your kind words. Moderators, thank you for doing what you do and helping keeping this train on its tracks. Appreciate you keeping this a safe and welcoming community for everybody. Thank you to the people who have contributed financially, keeping this stream going, supporting me as a starving scientist. Appreciate you putting food on my table with those subscriptions and gifts. Bits cheered. Thank you, new followers and raiders and even those quiet lurkers. Thank you for being here and getting those viewer numbers up. Appreciate that very, very much. Anyway, everybody, appreciate you. Until tomorrow, Thursday Birds Day, I wish you all a lovely evening and a lovely tomorrow. Take care, everybody. Let's go see Science Streams. I'll catch you there.